record right now?
cannot. Oh,
You
okay. I
cannot?
don't. Yeah, I can now. Wait,
Yeah,
no,
I can
can't.
record as well.
Are you guys able to record?
Yeah, I'm recording now.
I'm as well. Yeah.
Yeah, that's good.
Okay. So just now I guess everyone, y'all need to be aware that this is being recorded, obviously, for all kinds of reasons. Okay, so shall we continue now that we got that sorted out?
Yeah.
Okay, so we found the eigenvalues. Now we need to find the eigenvector, and the eigenvector is going to be the vector that when multiplied by the coefficient take away the coefficient matrix take away the eigenvalue is going to give us 0, 0. So obviously here we got a plus b equals 0, and the second equation is basically the same equation, so we're not going to worry about that. So we're on question 1 if someone is asking. Okay, anyways, so this means a equals minus b, and we can write our eigenvector as minus b, b, because a is minus b, and that can be simplified to b minus 1, 1. So this is the family of eigenvectors basically. What I recommend in the exam is to use like the simplest form. So here you would use minus 1, 1 to keep going. Anyway, so we got one eigenvalue. We got double repeated eigenvalue from what we found before, because the characteristic equation was this. So we got lambda 1 equals lambda 2 equals minus 1. But we only have one eigenvector. So what you need to do in this case is create a chain of generalized eigenvectors. And the way we do that is by following the formula. If you have a minus I lambda, which is the coefficient matrix subtracted the eigenvalue from the diagonal, just as we've been doing, multiplied by v1, that's going to give you 0, right? We just did that. That's how we found v1, right? Well, if we do a chain, then we have a minus I lambda multiplied by v2 is going to give us v1, and that is similar to a right. Or we could so here's an alternative form that could help you in the exam. If you look at the second equation, if I multiply by a minus I lambda on both sides, then I'm going to get a minus I lambda squared v2 is going to give you v1 a minus I lambda, and that equals 0. So something else you can use is this formula. Okay, so back to this. Now that we found we only have repeated eigenvalue, but one eigenvector, what we need to do is do the chain. So there's really multiple ways to do this. You could either use that the square multiplied by v2 is going to be 0, and or you could use a minus I lambda v2 is going to give you v1. So that's what I'm going to do this time.
Your
So
your camera's out of focus.
That's what I hate about these. Give me a second. Thank you for telling me.
Yep.
Can you see it now?
Yeah.
Okay. Yeah, I'm just using like from one of the classrooms, and this isn't my camera, so
It's all good.
yeah. Okay, anyways, let's keep going. So I will, give me a second. I will I don't think everyone has access to these questions. How can we do this?
The questions are the ones that you sent in the PDF.
Right. But some people are saying they don't have access. So does anyone not have access to the questions? Because I'm seeing in the chat. Or Okay, so no one said anything, so I'm gonna assume you all have access to the questions. Okay, so back to solving this, we got 1 minus 1 minus 1. That's a minus I lambda multiplied by some v2. I'm gonna say CD is gonna give me minus 1, 1. So this is a minus I lambda. This is v2. This one's v1. So I'm just gonna copy that back here.
Can you move your camera?
Yeah. Need to copy the equation here. Now I realize that wasn't the best way to do it, unfortunately, but oh well. So now we just need to find C and D. So this is C plus D equals C plus D is going to equal minus 1. The other equation is basically, well, the other equation is minus C minus D equals 1. So it's the same thing. So C plus D equals minus 1. Hold on a second. It's a bit weird because we're not supposed to get a solution like this with two independent variables.
Can you try 1, -1 for the v1 instead of -1, 1?
It's the same thing, right?
It'll just change your constants in front.
Yeah. Someone asked to send a link in a different group chat, and now I have to. So just give me a second, I'll be back. No need to worry. There's a trick that we can use here. Just taking a look at my notes. Okay, so well, we can I previously said that I keep getting okay, so I previously said that a minus I lambda squared v2 equals 0. So you can use that method to get a v2 as well, since we solve an equation with 0 on one side is going to be a safer bet. So we're going to have 1, 1 minus 1 minus 1 squared v2 equals 0. v2 is a vector, my bad. And that's a 0 vector. So what we can do here is, because the square of this equals to 2, you can try to do that in your head if you don't believe me, but the square of that is equal to 0. So I'm just going to write it here for clarity, but
You're out of focus again.
all right, yeah. All right, so I'm just going to write it out for clarity, but it should be obvious to see that for this kind of equation, any v2 could work. So what I'm going to do is I'm going to pick v2. So what I'm going to do is I'm going to pick v2 to be equal to something like 1, 0. And because we know that that satisfies the equation, we can do v1, which was our matrix 1, 1, minus 1, minus 1. So we can use a minus I lambda. V2 is going to equal v1. And so that's going to be 1, and then it's just going to be minus 1, which is what we have found already. So if you remember earlier, we found v1 to be that. So you could skip this step in an exam, but I'm just showing it here so that there's no confusion. So we now have a V2, we now have a V1, we know our eigenvalue is repeated. So I'm gonna also show you this little cool trick when you do chains of eigenvalues for how to write your solution. So if we have V1, and V1 is a real eigenvector, we didn't get it through the chain method like this, that's what I call it. So if V1 is a true eigenvector and we didn't get it using the chain method, then we chain that to get V2, so like so, then that means when we write out the solution, this one is gonna have a T, and this one's just gonna have, so this one's gonna have a T, E lambda 1 T multiplied by V1. This one's just gonna have E lambda 1 T V1, and that all of that is going to be the solution. So if I had and the idea here is that as I go to the left, I will be multiplying by T. Okay.
Well,
So
you wrote
now,
V1. Do you write V1 twice, like you wrote, or do you write, is one of them V2?
what are you talking about? This one?
No, the line below it. You have V1 and as well as V1. You wrote
Yeah,
T.
V2. It is supposed to be V2, yes. Okay. So now we can write our general solution as follows. It's going to be C1e to the lambda t, C1e to the lambda t, multiplied by V1. And we have determined V1 to be 1 minus 1. So now that's the first part of the solution. The second part of the solution is going to be C2e lambda t. And we know lambda in this case is minus 1. And we know lambda in this case is minus 1. So we can plug that in if you want. But then what's going to happen here is that you've got T, as I said, it's going to be T multiplied by V1 for the chain part of the solution. So it's going to be T 1 minus 1 plus, what is that going to be? 1, 0, because V2 is 1, 0. So there you go. Now you've got your general solution. And if I can, just give me a second to pull back up the initial condition. Or actually, before we write the initial condition, we can simplify this further to make our lives easier because it looks like a mess. So we can say x is going to be C1 e to the minus t 1 minus 1, but I'm going to rewrite the second term.
Lower the paper.
Yeah, I can see. C2 e minus t is going to be, so we had t multiplied by 1 and t multiplied by minus 1. So that's going to be t plus 1, and the bottom is going to be just minus t. So we have t plus 1, and the bottom is just going to be minus t. Now we have the initial condition to be when x is 0 equals 1, 2, correct? So what we can do with that is, if you plug in 0, then you have no exponentials, right? Because e to the power 0 is just 1. So what this leaves you with when we plug that in is going to be C1 1 minus 1 plus C2. Well, t is 0, so that's just going to be 1, 0. And we know that has to equal 1, 2, right? So, okay, yeah, so we know that has to equal 1, 2. So then we can, this is just a system of equations. We can say that C1 plus C2 minus C1 equals 1, 2. So then we know that C1 is going to be equals to minus 2. And yeah, C1 equals minus 2. And so C1 plus C2, for that to equal 1, C2 would have to be 3, right? So now back again, we can go back and write our solution as C1 is negative 2. So it's going to equal negative 2 e to the minus t 1 minus 1 plus 3 e to the minus t plus 1 minus t. And that is our solution. So let me just take a look at the answer choices. Hopefully we didn't totally botch it and you have a chance of getting it right. So the top part is the top part is going to be minus 2 plus 1. That's no, minus 2 plus 3. So that's going to be plus 1 and 3t. So we got 3t plus 1 on top. And then if we compute the bottom, the second row, we have e minus 1. We have minus 2 minus 1. So that's going to give us 2. We have 3 multiplied by minus t. So we have minus t plus 2. And so, wait, minus 3t plus 2, since we have the 3 here. I made a mistake. Okay. So this is answer choice A. And by the way, all the answers in this exam are A. So any questions about how to solve this one?
How did you get
I
V2 again?
Okay. So yeah, this is the page. So here, I'll take a new page. So to explain the rule of, let's say you have repeated eigenvalues, then depending on how many eigenvectors you get, you may need to make a change. So actually, let's just get this out of the way. I'll let you know every single possible. So it's gonna take me like maybe 5 minutes to say, but it's better because in the exam you're gonna have one of the, so well they're not gonna give you a 4x4 because that's gonna take time. So I'll do everything possible for 2x2 and for 3x3. So I'll start by 2x2. If we have a 2x2 matrix, okay, and you get repeated eigenvalues. So here I'm specifically talking about repeated eigenvalues, not complex, not unique, repeated eigenvalues that are real numbers. Well, complex can't be repeated because there's like a conjugate. It's 3 plus minus bi, for example. So repeated eigenvalues for 2x2, you only have 2 possible solutions. You either have 2 real independent eigenvalues. Do you all remember how if eigenvectors, sorry, do you all remember how do you find if vectors are independent? Or do I need to explain that too?
I'm gonna say no. That's why most of us are here. But
Okay. So
yeah,
okay,
can you go over that quickly? That'd be cool.
All right. So well, in simplest terms, if we only have two vectors in general, they are only independent if one of them cannot be written as a multiple of the other, if that makes sense. Does that make sense?
Yeah.
So yeah, okay. So if we do a 2x2 matrix and you get repeated eigenvalues when you do your determinant something equals 0, like we had, but you get 2 real independent eigenvectors, then that means you have to then that means you're in safe hands, because it's much simpler, and your solution is going to be x1 of t is just going to be some constant e to the, so I'm just going to specify that lambda 1 equals lambda 2, so equals lambda, so I don't have to write a subscript, so all of them are lambda. So e to the lambda t multiplied by, so we have 2 v1 and v2 multiplied by v1. And your second one is just going to be, let's say, another constant, b e to the lambda t v2. Does that make sense? So if I have 2 independent eigenvectors, it's much simpler. All I have to do is say that the solution is going to be, of course, the sum of x1 of t plus x2 of t. That would be like the whole solution. Is that clear? Do you all get this? Okay. Okay. So what if we only have one eigenvector, which is what we had here? Well, if you only have one eigenvector, then you write your x1 of t is still the same. So you're gonna have this time v1 is like the eigenvector. So x1 of t is still gonna be this. So if you go back to our work in this question, part of our solution, you see this? This is just the constant times e to the lambda t multiplied by the eigenvector. Here you have the same thing, constant. So the question is usually, how do you find v2? So well, the way to find v2 is you can use this formula. So if we have some real eigenvector v1,
Can you move it down?
I can, yeah. And how do I find a chained or a generalized eigenvector? That's the technical name. Then you have to follow the sequence of formulas where a minus I lambda v1, that should give you 0 because v1, as we said, is a real eigenvector. Then you have a minus I lambda v2 is going to give you v1, a minus I lambda v3 is going to give you v2, and so on. You get the point. This is the 0 vector row. Sometimes it's customary to write it like this. So the idea is, as you go down, you get, so v2 and v3 are all chained or generalized eigenvectors. That's the idea here. Now, what I like to show here is that if I take the first two equations, and let's say I take the second equation, this one, and I multiply both sides by a minus I lambda. What does that give you? That gives you a minus I lambda squared multiplied by v2. But the second side is going to be v1 multiplied by a minus I lambda. So what is that going to be? Because v1 is a real eigenvector, then that has to be 0.
And that's 0.
Sorry, what?
So you're saying that when you do a minus I lambda squared, you can set that times v2 as 0 and then solve using the same way you found v1?
Correct, but only if, yeah, well, I mean, this is always true. A minus I lambda squared multiplied by v2 is indeed going to give you 0 for a v2 that is a chained eigenvector of v1. And so the way we always,
the only thing was that for question 1, a minus I lambda squared was 0. So you're kind of like, you
correct. So this is the, when you get like a square or a cube of it is going to give you 0, then this means this equation is satisfied for any v1, right? For any v2, sorry. Correct.
I think it basically means that since the characteristic equation is equal to 0, that means you could pick any value for v2 to be, and it'll just end up being true.
Exactly, because a minus I lambda squared is happen to be 0. So any v2 will work. So what I encourage is to look for situations like this when a minus I lambda squared is going to be v2. And then you can pick any v2. And then you can plug v2 back into this equation and find v1. Okay. So now I'm going to go over real quickly the 3x3 case.
Oh, so you're saying you find v2 before v1?
Yes, you can totally do that if a minus I lambda squared is 0. That's the way to do it in an exam. In fact, that's how they would expect you to do it quickly. There's no other way to do it quickly.
To find v2 first by identifying that a minus I lambda squared is 0, and then you put in some arbitrary v2 and then get a v1.
Yes.
like in this one we did, if we found a V2 first, if we picked 1, 0, and then multiply it by the matrix, which is 1, 1, -1, -1, you would multiply that and you would get 1, -1 still. It would just end up being faster.
Yeah, okay. I mean, the shortcut method I used, I was able to get 1, -1 immediately for V1, but then I was kind of stuck with a V1 and I wasn't sure how to get a V2.
Right. I'll double check into it. Why? Because I ran into a bit of an issue when I tried to do it the normal way, finding V1 first. Let me take a look. Yeah, so we had this. Well, okay, so here you can look at, this is another way. So if you find V1 first and you plug V2 into the normal equation, you get this, right? Can you see?
Yep.
Okay, so when you get this, what are some values of C and D that satisfy C plus D equals -1?
It could be -1 and 0.
For
That's
example.
Simplest.
So really, it would also work that way because you found a V2. Does that make sense?
Yeah, that's the way that I would usually do it. I don't usually
Right.
do the A minus I lambda squared.
Well,
That makes sense.
I usually recommend the A minus I lambda squared as a shortcut when you have a triple eigenvalue, because then you're not gonna repeat the equation twice. That's gonna take a lot of time in an exam.
That's
So
true.
back to the 3x3 quiz, just so we could get this portion quick with and not have any. Well, feel free to ask questions even after, because it's gonna come up in a different question. If you have a triple eigenvalue like this, so if you have 3 independent eigenvectors, then the solution is going to be the simple one, so it's going to be, if we have 3 unique independent eigenvectors, then the solution is going to be the one, so a lambda t.
How do you know you have independent or dependent eigenvectors?
It depends on how many eigenvalues you find.
Well, not really. Well, the way you know if they're independent or not is if a vector can be written as a multiple of. That's why I asked earlier, because that's key to it. That's why I asked earlier. You guys know how to find if 2 vectors are independent. So if one of them cannot be written as a multiple of the other, then you can know.
It's like 1, 2, and 2, 4, basically, right? Like those are dependent.
Exactly.
Okay.
If you had 3, well, here's the thing: when you solve the equation here. So when you solve the equation, you can. This is why I follow this method. Can you all see that here? Can you all see that when I solve this in order to find V1, can you see that even though anyone could tell this is -1, 1 is a solution, right? Just by looking, I don't really need to write anything. I still wrote it as V1 equals -B. And the reason I do that is because I want to separate the different variables, because the number of different variables I have is going to dictate how many independent solutions I have, if that makes sense.
Yes.
Are we? Yes? Okay.
No, I don't get it. Can you explain?
Okay. So here, I'll open it. Blank page. So suppose I solved some kind of system and I found that this is the class of solutions. Well, I picked a really bad one, but you know, it doesn't matter. Okay, so suppose I have this, then I could have any, so then my total solution is going to be A, B, right? If I have two variables like this, it means I can have two independent solutions, because regardless of what I pick A, if I pick B to be a certain number, and even if A is 0, then it's still a solution. Does that make sense? Like, it is independent of this, whereas in contrast, if I had minus B, B, which equals B minus 1, 1, if I pick any B, then my answer cannot be different. You know what I'm saying? Like, my answer is always going to be the same for the same B, whereas here I could pick the same B, but A could be different. So my basis, I guess that's what they call it in linear algebra, the basis of the system is two. Like, you have two independent. Does
Okay.
that make sense?
Yeah, I kind of get it. So basically, if B influences more than just the first, like more than just one row, then it's like basically it's not too independent. It's dependent.
Right, because let's do a small exercise. So if I had this, if this was like the way I broke down, how many independent eigenvectors do I have in this solution? So that would be A plus B. The bottom part would be B. The middle part would be B. Sorry, the bottom part would be A plus. Yeah, it would be A plus B. So here I have two independent two independent vectors. So 0, 0 is not independent because it can be written as a multiple of the others. That's something you could see. But I'm just trying to convey the idea here.
Okay.
So
So
is
out
my,
of three,
oh, sorry.
you go.
I was just going to say, so is my assumption that the number of eigenvalues that you find is the base number of unique solutions you'll have? Is that wrong?
That's wrong. That's wrong. Yeah.
Okay.
Because some matrices are defective. So when they don't have what you just said, we call them defective, and we have to use the chain method, which is. So if we got the independent vector state sorted out, then it should be easy to keep going on and see that AE lambda t v1 plus BE lambda t v2 plus CE lambda t v3 is going to be your full solution. That is only true when what you just said would be true, which is you have v1, v2, and v3 are all independent. Okay. Now let's say I have, and this is let's say I have the same thing, triple eigenvalue, but let's say this time I had only one independent eigenvector. What is your solution going to look like? So if you only have one independent eigenvector, and this means this corresponds to a, I've only tested this with 3 by 3, but if you only have one independent eigenvector, then your geometric multiplicity, which is just a fancy word for A minus I lambda, it's a 3 by 3 system. So if I only have one independent eigenvector, believe it or not, A minus I lambda cubed is actually 0. So you can start with any v3 and work backwards, just like we did. So I'm giving you the shortcut that I would like honestly use in an exam. I'll have one.
Oh, that makes sense.
Yeah, if I have one independent eigenvector, this is true, and you can use that to work backwards, just as I've done.
But the hard part is identifying how many independent eigenvectors you have, basically.
Well, that's just solving the system of equations, so it hopefully shouldn't be too difficult, right?
I
It's
just
not
feel
really.
like if we can do an example where like you have like examples of like identifying 1, 2, or 3
Okay.
eigenvectors like that.
Well,
like,
we can keep doing the questions
think-
and then like hopefully we'll come up.
I think the next one has one. It gives you an independent eigenvector, and then what is
The
the 2 by 2?
no, the next one is complex eigenvalues. Yes, the next one is a bit different. Here we're talking specifically about repeated eigenvalues, but
Yeah.
the next one is complex eigenvalues. So for continuity purposes, I will skip number 2 because like we've done some explaining for this, so I want to get to a part where we can use it before, so we can apply what we've learned. So can you all go to question number 3? Okay, so question number 3 is actually it's a bit tricky at first, but it's simple. So it's saying x prime 1403 x of t. And what they're asking us here is what would the limit of x of t be if you start at 1, 0? Okay, so the way you would solve this this kind of question is try to identify the stability of the system, as in do the solutions tend to 0 as time increases, or do they keep on increasing indefinitely? So if it tends to 0 as time goes on, then we call that stable in general. And if it doesn't, if it expands indefinitely, then we call that unstable. So remember that we write our solutions as, in the simplest way, we say like one part of the solution, x1 of t is like this.
Yeah.
Well, I hope you can see that if we have a solution, say like it's in a really, this is lambda 1 t, and I'm just here trying to give you the core idea, which is if we write this, it's going to be AE lambda 1 t plus BE lambda 2 t. I'm trying to give you the intuition that if, let's say, both lambda 1 and lambda 2 are greater than 0.
Yeah.
What would happen then as time increases for x of t?
It would go to infinity.
Right. So the idea here is that the signs of the eigenvalues can help you determine the stability of the system. So if I have 2 positive eigenvalues, it goes to infinity. If I have 2 negative eigenvalues, it should be obvious that it goes to 0, right?
Yeah. And
Okay.
if you have 1 positive and 1 negative, then like it's like on like you don't know, or does it still go to it depends on the coefficient and the
It depends on well, here's the thing. It depends on 2 things. It depends on your coefficients, like you said,
Yeah.
but it also depends on your starting position, right?
Okay.
So here they've given us a starting position, but let's solve the question and see if we get let's see the eigenvalues we get. So I'm gonna skip because we've done finding eigenvalues before. So determinant of coefficient matrix, take away eigenvalue is gonna be the determinant of 1 minus lambda, 4, 0, 3 minus lambda. That's gonna be 1 minus lambda multiplied by 3 minus lambda. And that would be take away 4. So then we set that equal to 0.
I don't think it would be take away 4. 4 times 0 is 0. So it would just
Oh,
be
4
1.
times 0 is 0. Yep. Thank you.
Yep.
Yeah, I don't know what's happening with me. Okay. Yep. 1 minus lambda multiplied by 3 minus lambda. So therefore we have lambda 1 equals 1 and lambda 2 equals 3, right? Because you set that to be 0. So therefore, both your eigenvalues are positive, correct?
Yeah.
So then, regardless of what your eigenvectors or whatever it's going to look like, because they're both positive, you know that the solution, you know that wherever you start, well, I guess unless you start at 0, 0, right? If you start at somewhere that's not 0, 0, then you know you're going to tend to infinity, right? Is that clear for everyone
Yeah. I
in
got
an
it.
intuitive way? Okay.
Do
All
you,
right. So then,
so quick question, let's say it was like what we did up before, there was like squared value and that end up being 0. So you would have like this value plus this value t over this value. So if there was a t in there and is asking you to find the limit as t approaches infinity, would that
how do you
just,
do it?
yeah,
Okay.
would that just be infinity as well?
Good question. And what I recommend here, unfortunately, we're very close to the exam, so
Yeah.
which is tomorrow, I guess, for everyone. That requires some. So I'm gonna switch to my computer here. Well, what I recommend is for everyone to. Well, see, it's not. That's why I cannot recommend, because it's not. But for that question, the knowledge you would need is you would need to know all the face portraits, basically, if you remember that.
Oh. I'll
You
okay.
might say that's not on the exam.
No, it's on the
I-
exam. There's a
is
question on
on-
here that's a phase diagram.
Really?
Yes.
Are we gonna get? Or we're not gonna be given those, are we?
No.
Oh,
It's it's a bit of a shame. I don't know
For
what to
those
say about
ones, I
that.
would say if your professor lets you have a sheet, write them all down. Otherwise, just take the loss. It's not worth it to try to remember all
Yeah,
this.
I think there'll only be like one question on it, so it's not going to be the end of the world.
Yeah, I mean, just keep in mind that like, if you have two positive, you know it's gonna be like unstable. If you have two negative, you know it's gonna be stable. If you have one positive, one negative, you're not sure, but you know that it looks like a saddle point if you've seen that before. So I mean, those are
two positive.
two positive. Like in this case, it tends to infinity. Two negative, it will tend to 0.
Okay.
One positive, one negative, it looks like a saddle point, which is to here. Okay. So share screen. Can you see this screen? That because I cannot tell if you guys can see.
Yeah, I can.
Yeah. Yeah. So this would be a saddle point, for example. So yeah. Well, as has been said, I don't think, maybe like you're only going to be tested once or twice on knowledge of face portraits.
Yeah,
But
there's
you
a
know, if
question
it
on number 6.
yeah, if it comes, but that's a bit different. I'll explain that in a bit. Those are for what do they call them? Like linear homogeneous systems, I guess, because they can be written in, you know, 4 constants in the matrix multiplied by the x1, x2 is going to give you x prime. But yeah, I mean, it's definitely not like only memorize if you have extra time. There's definitely other things to review, and keep the basic idea that, you know, if the signs of the eigenvalues can really help you know. So I mean, you can look at this even for a saddle point. The bigger eigenvalue determines. So like, it should be intuitive. It should be. Hopefully, they don't put something where it like looks like this, or where are they like improper nodes.
Can you send that link in the chat, maybe, or something?
Sure.
Thanks.
So how do I'm trying to figure out how I go back. How do I go back? Sorry for the technical difficulties, everyone. Oh, there we go. Now I'll send the link in the chat. Okay, so next question, because it's been 55 minutes and we've only gone through 3 questions, because that's fine though, at least we're getting something out of the discussion. Okay, so is everyone on question 4?
Yeah.
Yep.
Are we gonna revisit 2 later, maybe?
Yeah,
'Cause we just
sure.
skipped it.
Yep,
All right.
yep, I know. But I'm trying to do that in the interest of
Yeah,
time. Okay, so if we have a spring mass system, and unfortunately, I can't really say anything about this question except that you need to know like the physics behind it, otherwise you cannot. Unfortunately, I don't know what to say. But if you have something like this, where x1 is defined to be the equilibrium position, and x2 is positive to the right, then the way you solve this question is by drawing the free body diagrams, if you learned that in physics, and then you sum the forces and write your Newton's second law equation. So if we do that for M1, well, you don't really need to write this, but I'm only going to write the horizontal forces. So suppose so for these questions, simulate what would happen if you move the variables in positive direction. So if x1 is positive and you stretch it, then the spring is going to want to pull back. So that force is going to be K1x, right? K1x1, sorry. Now, the tricky part is what happens to the other spring. Well, it's definitely going to have to do with the difference of x1 minus x2, right? I want to know right now, does everyone get some kind of intuition that whether the second spring is compressed or stretched? Can you see that it's somehow related to how x1 and x2 both displace, and it's not just one of them?
Yeah.
Okay. So what you do here is you can write x1 minus x2 or x2 minus x1. Doesn't matter. What matters is the direction of your force. So we know the force is going to be K2 multiplied by this, but let's say for a moment that x2 was 0 and x1 was positive. That would mean that your spring is going to be compressed. Therefore, you draw the force like this. And now it works in any case in general. That
Wait,
is, if you're okay. First, you know K1 x1. This is for M1.
Mm-hmm.
So the second one is going to be K2 x1 minus x2, but you don't know the direction yet.
Yeah.
The way you figure it out, and that is very, very important. Suppose, okay, I'll make it very clear. Suppose that you see x1 is positive to the right. Suppose x1 is positive, and x2 was negative. Would the spring be compressed or stretched?
It'd be compressed.
It would be compressed. So if it's compressed, where's the force going to point?
To the left or towards M1.
Yes, to the left for M1. So that's how you draw it. And now it becomes true for any general case. For example, if x1 was negative and x2 was positive, then you're going to have a negative number here. But it's okay to have a negative number here, because then what that means is that your force is going to be reversed to the other direction. Is that clear?
Yeah, and if it was x2 minus x1, then it would be in tension, correct?
Right, it would just mean the direction is. So what you need, I guess what I'm trying to get at here is you want your free body diagram to be consistent with what you write, x1 minus x2 or x2 minus x1. Does everyone get that?
Kind of, yeah.
If it's not, so let me give you an example of something that would be inconsistent. Suppose I wrote this pointing to the right. Why that wouldn't make sense is because suppose x1 was positive and x2 was 0, then that would mean that the spring would be pointing.
To the right.
Yeah.
No,
Yeah, it would be pointing to the left because the spring would be compressed, right?
yeah.
So you just need to, you need to be consistent. And generally, I will always recommend you to see what happens if x1 is positive. So try to go with the predefined directions. Obviously, there's no problem if you reverse them, but then, you know, just try to work with what's given. That way you will reduce the chances. So they gave you in the question x1 is to the right. So when you try to draw the FBD, think what happens when x1 goes to the right, because that's the positive direction. Don't try to define it as to the left, because even though you could still get a correct answer, you know what I mean? You'd have to reverse one. Yeah, okay.
So
So
we define x2 to the left. They're defining x2 to
no,
the right.
x2 is defined to the right.
Yeah, but didn't we just define x2 to the left so that we can write out the equation?
No, I didn't define it. I defined it to the right.
We said
So-
x1 minus x2 is in
Yeah.
or compression, so that's why it's acting to the left, not that x2 is acting to the left.
Okay, gotcha.
Yeah. Are we clear on that? Please ask questions if you don't. This is what this is for. Okay, so if there's no questions, then basically at this point your problem is indeed solved, because from physics, you know, sum of forces in x direction is going to be your mass multiplied by your acceleration in the x direction. So we can also write your acceleration in the x direction as x prime prime of t, from physics, right? So if we're talking about block 1 specifically, we say m1 x1 prime prime is going to be equal to, well, x1 is to the right. So if a vector is showing to the left in the image, I write it in the equation as minus k1 x1. Then same thing applies for this one. It's going to be minus k2 x1 minus x2. So that would be, is that an answer?
Because they have
Yeah,
x2
so-
minus x1.
Yeah, okay.
Yeah.
Okay, so it is the same thing basically, but yeah. Yeah, you could rearrange that, and I'm gonna skip mass number 2, but the correct answer is A, and you use the same method. So you can see for block 2 there's only K. So hopefully that makes sense. Okay, so number 5. All right, this one's gonna be, well, interesting to say the least, but okay. So x, I just want to make sure I'll see it. So x prime of t, and we're on number 5, by the way. So x prime of t equals this coefficient matrix 0, 1, 2, minus 5, minus 3, minus 7, 1, 0, 0. X of t. Well, your first step in these kind of questions is usually to find the determinant, set that equal to 0, and find the eigenvalues, correct?
Yes.
Well, I want you to notice that in the question, they don't want you to do that. They recognize, whoever wrote this question recognizes it's an exam and wants you to save time. So if you write the determinant for something like this, it's going to be cubic, right? So cubics are generally, you know, more time consuming. So they just gave you the characteristic polynomial to be minus lambda plus 1 cubed equals 0, correct? So that means we can say that our lambda 1 equals lambda 2 equals lambda 3 equals minus 1. All good up to this point? Because I don't want anyone getting lost in this. It gets long.
Yeah, that makes sense.
Okay. And please correct me if I do make any mistakes, as this is, you know, it's going to have multiple steps. But anyways, now our next step is to find how many independent eigenvectors there are, because, you know, that judges how we work with these kind of problems, as I said before. So we write our A minus I lambda is going to be minus lambda 1, 2, minus 5, minus 3 minus lambda minus 7, 1, 0 minus lambda. However, I know what lambda is, therefore, minus lambda is just 1, 1, 2, minus 5, minus 3 minus lambda is just minus 3 plus 1, so that's just minus 2. Okay, minus 7, 1, 0, 0 plus 1, 1. Okay, therefore, this is my a minus I lambda. Now I have to find the eigen. I'm going to do this in the next page because solving system of equation. Wait, what was it? 1 minus 5. Please do let me know if I did copy it wrong. It's 1 minus 5, 1 minus 2, 0, 2 minus 7, 1. And by the way, I forgot to say this in the beginning, but when we're working through these problems, really, if you want to get something out of it, you got to be, you know, having your pen and paper ready and working it with me as I go along the problem. And, you know, otherwise you're just not going to get as much of it as you could, or at least that's what I think. So anyways, back here, we need to find the, oh no, sorry. We need to find the eigenvalues, so A, B, C is, okay, sorry, I got cut off because someone came in. Anyways, back to finding the eigenvalue again, and I'll write the formula again. A minus I lambda, V1 equals 0, and V1 is going to be a true eigenvector. So there's a bunch of ways you could solve this, but I'm going to go with the traditional way of turning it back into algebra. So that gives me A plus B plus 2C equals 0, minus 5A minus 2B, and now I recognize there's a shortcut, but anyways, minus 5A minus 2B minus 7C equals 0, and A plus C equals 0. So we start off the bottom one, we can see A equals minus C, right?
Yep.
We can use this to plug it back here and see if A is equal to minus C, then B plus C is equal to 0, which lets me know that B is minus C, which also equals A. I'm going to use the last equation to verify, like we already have A, B, and C, like everything is defined, but I will try to do it just to verify that it is correct. So minus 5A is the same thing as 5C, according to our equations, plus 2C minus 7C. Does that equal 0? Yes, okay. So this, the last thing I did in an exam, I don't have to do it, but I just did it to check because before I proceed, because the number of independent eigenvalues will greatly differ how the solution looks like. So, well, we are in luck here because if you write the solution to this, A, B, C is our V1, right? So if we write the solution to this, A is going to be minus C. Well, B is also A, which is also minus C. And C is just C, right? So that means we can write it as C minus 1, minus 1, 1. Wait, C minus 1, minus 1, 1. Okay. So question here, how many independent eigenvalues do we have? In eigenvectors, I mean.
Just one.
Exactly, just one. Is that clear with everyone?
Yep.
Proceed. Okay, I will proceed. I may miss the chat, by the way, so you should depend on your, just saying, you should depend on unmuting and saying what your question is. Okay. So remember this before, I already told you, if you have one eigenvalue, and I showed you this trick before, I said if you have a 3x3 matrix and you have repeated eigenvalue, triple, and you have one eigenvector, so it means your it means a minus I lambda cubed is actually going to be 0. And just for verification, if if people are not going to believe me, I will not do this on paper in the interest of time. However, I will go to Symbolab. I will go to this matrix calculator. And that will be 1, 1, 2, minus 5, minus 2, minus 7, 1, 0, 1. If I cube this, it should be 0 if we are correct. And lo and behold, it is 0. And it should, for a 3 by 3 matrix, if you only have one eigenvector, it should make sense that your cube of the coefficient matrix is going to be 0.
So you think they're always going to give it to us as 0?
No, not always. They could give you 2 eigenvectors, for example.
How do you
That
find
would
the
be-
second eigenvector then? How do you, like, after finding V1, how do you know you have to stop and this is only one eigenvector? That's my question.
Okay, say that again. Sorry, I didn't get that.
So you said that if you have one eigenvector, then a minus I lambda cubed is 0, correct?
Correct. So what is the
My question is, how did you know that you have only one eigenvector? Like, you stopped after finding V1, you didn't attempt to find a V2. Like, you knew that there's
because
only one.
Good question. Because it's not. Let me correct this. It's not one eigenvector. It's one independent eigenvector. Keyword independent.
Yeah, but how did you know there's only one independent? That's my question.
Because, okay, what is all my possible solutions? All my possible solution is C minus 1, 1, correct?
Okay.
Can you see that for any C I pick? So let's say I use 2 different C's and I got 2 different eigenvectors. Can you see that one of them is going to be a multiple of the other?
Oh, okay, please, okay. Gotcha.
Can you see that?
Yeah.
Yeah, so I only have one. If I solve the system of equations, right, I only have one independent eigenvector. This is all from linear algebra. So yeah, unfortunately, there's no way around it. You gotta know how to identify independent eigenvectors, or it's just impossible to solve these kind of questions.
Gotcha.
Yeah. Okay, so if you only have one independent eigenvector, then your cube of the coefficient minus a minus I lambda has to be 0. This is true. I verified it myself on multiple occasions. My professor gave us a hint in my first exam. If people were in Menezes, the professor said, one of the hints was
Yeah, I remember.
was a triple eigenvalue, and you'd only get one eigenvector. So he said he expected everyone to just look at the question and without even doing V1, just skip to. Though I don't understand how that is possible, because I personally would still calculate V1 to understand I still have one eigenvector. Because if I had 2, then it's totally a different story. It's not the same. Okay. So therefore, now we know a minus I lambda cubed. Well, the equation is like this too. Is everyone aware where this equation comes from, or you want me to show one more time? Please ask if you are unsure where this comes from. And V3 is not a real eigenvector, it's a chain.
Would you mind
So that-
yes, sliding it up a little bit? Sorry, we can't see. Thank you.
I remember this. We were just
Yeah.
Okay, so again, and I was only able to know that this is always true, but I was only able to know that this part is 0 because it's a 3 by 3 and I had one independent eigenvector. It has to be 0.
And if
It
it was
has
2
to
by if it was 2 by 2, and it would be squared then, right?
Yes.
Okay.
Right. It was yes. Okay. So this is only when I have one independent eigenvector. I keep repeating this because I don't want people going to exam assume that cube of this is 0. And it does not, that's not how it works. It's not always. It's only true when you have one independent eigenvector. So this equation is always true. However, I know that this part is 0. So if I know that this part is 0, any V3 works. I keep forgetting my little vector arrows, unfortunately, but oh well. So any V3 works. So now you're gonna say, what can I do with a V3? Well, if I know what my V3 is, then I can do this. V3 is gonna give me V2, A minus I lambda. V2 is gonna give me V1. That way I picked my V3, I computed V2, I plugged back V2 and I computed V1 though. That shouldn't be totally necessary because I already know what V1 is, but for demonstration, I will actually compute V1 and show you that it is equal and consistent, that the math is consistent. So let's go ahead and do this real quick. I'm gonna pick V3. Oh, by the way, do not pick V3 to be 0, okay? Please do not pick V3 to be 0, okay? Like 000.
Yeah.
Yeah, I hope that should be obvious that's like the one thing that will not work. And also don't pick V3 to be the same as V1, obviously. Don't pick it to be this or a multiple of this. It has to be like some random. Basically, the criteria for V3 to work is you just don't want it to be like a true eigenvector, something that A minus I lambda multiplied by that is going to give me 0. So anyways, I picked that to be 1, 0, 0. Does someone have the matrix written? Could you like tell me what?
The answer or the
No, the coefficient matrix minus the lambda.
oh,
Well,
so it was
it's
1,
1,
1,
1,
2, -5, -2, -7.
all right. And
And
then
then
the bottom was
1,
1, 0, 1, right?
Yeah.
So now I'm going to do 1, 0, 1. And I hope it is obvious that this is -5. Wait.
Okay.
Yes.
And then that 1 -5, 1 is V2. Okay.
Yeah, there we go. Yes. So I'm going to compute V1, but in an exam, you got a problem like this. You do not need to do V1, but I'm going to do it just to show you that it is indeed consistent. So I'm not going to skip steps. I'm just going to do it basic. So 1 times 1 is 1. 1 times -5 is -5 plus 2. It's going to be, hold on a second, 3 minus 5 minus 2. Okay, -5 times 1 is -5 plus 10 minus 7. So
-2.
minus 2.
So it's a multiple of it.
Yeah.
And the last one is 2.
So do you see that V2, do you see that the V1 we computed is basically this?
Yeah.
Okay. Now on to writing our answer. And I'm just trying to pull up the questions. Keep losing. Okay, I found the question. Okay, so now we need to write our general solution. Oh wait, you cannot see probably. XT equals C1 e to the, what was lambda? I forgot, -1, right? -1.
yeah.
So minus t, well, V1, and I know what V1 is. It was, well, it was just -1.
-1, -1, 1.
Yeah, that works. Or you could put -2, 2. It doesn't really matter.
You'll just change your C1.
Yeah, exactly. Yeah. T. Now, what you're gonna have here is, as we said when making a chain, here. So this is the diagram I like to use. Let's say I have V1, 0. If I multiply V1 by A minus I lambda, it's gonna give me 0, right? And by the way, this is just like a mnemonic thing to show you. v2 multiplied by a minus I lambda, same thing is going to give v3, same thing. Okay. The way we write our chain solutions is that so we're going to have C2 multiplied by a chain of 2 plus C3 multiplied by a chain of 3. So for a chain of 2, I will have V2 and V1 involved, right? So what happens is I start with a 1, and then I integrate that way to the left. So if I integrate 1, that's just going to give me t with respect to t. So if I integrate 1, it's just t, yes. Now, so that's for chain number with a chain of length 2, because you have two V2 and V1. For the chain of length 3, I start from 1 here. What is that going to be? T. This one's going to be t squared over 2. Can you all see the pattern?
Can you move up the screen a little bit? Sorry.
Yeah, you're just integrating with respect to t.
Yeah.
Basically.
When you go, yeah, when you go to the left, yeah.
So for the value, should it be -2, -2, 2?
It doesn't matter.
Yeah.
Okay, I thought it
That's
might
like-
have mattered for like a 3 chain. So
It's only going to change your coefficient value for C1.
okay.
Or all of them actually, because it's all getting multiplied by C1, C2, C3.
Okay.
What was our V2?
1 minus 5, 1.
Made a mistake. This is not supposed to be 1 minus 5, 1. What's supposed to be attached to the t is V1, which is -1, -1, 1, plus well, what's attached to just 1 is going to be V2, which is -1, -1, minus 5, 1. Keep it better. Yeah, wait. Is it 1 minus 5, 1 or 1 minus 5? Sorry, I'm a bit. It's 1 minus 5, 1, right?
Yeah, it should be 1 minus 5, 1. Just the negative on the 5.
I'm really sorry. 1 minus 5, 1. Okay. That's my third and my last part. I'm just gonna write like this. Not really organized. Sorry for that. Well, no, I cannot write it like this. Well, this part is my x1 of t. This part is my x, like second solution. I still need to write. So this is like x1 plus x2. So I still need to write x3 of t. So x3 of t is going to be c3 e to the minus t. Well, we look at this. T squared over 2 is attached to v1. So t squared over 2 minus 1 minus 1, 1. Plus t multiplied by v2. V2 is going to be the 1 minus 5, 1. Again, is that annoying vector. And then the last one is, what is v3? 1, 0, 0. Okay. So our solution is x2 plus x1 plus x3. But let's look a little bit about what the question's asking. The question wants the full solution. So they basically want you to find C1, C2, C3. It should be clear that all you would need to do is plug in x of 0 equals 0 minus 1, 0. Therefore, what we can instead do is try to simplify the problem. So here, since we're plugging in 0, we don't need to worry about exponentials at all. So here we have C1, e raised to the 0 would be 1. That's going to be C1 minus 1 minus 1, 1. Well, as for C2, well, if t is going to be 0, then I forgot this, by the way. If t is going to be 0, then all of this is going to go to 0, and I only need to care about 1 minus 5, 1. And then same logic for C3 is just 1, 0, 0. And all of that is supposed to be equal to the initial condition, which is 0, minus 1, 0. So now we should be able to solve minus C1 plus C2 plus C3 equals 0. So minus C1 plus C2 plus C3 equals 0. Minus C1 minus 5C2 plus 0 C3 equals to minus 1. And finally, C1 plus C2 equals to 0. So from the bottom one, we can say C1 equals minus C2 definitely. Wait a second. Okay. And now we plug that back into the second one. You have C2 minus 5 C2 equals minus 1. Just double checking. So that is to say that C2, so this is the top part is basically minus 4 C2. So then C2 is going to be just 1/4. Is that correct? 1/4 minus 5/4. Yeah, that is correct. Okay. And C3 is now, so I know C2 is 1/4. I know C1 is minus C2, so it's minus 1/4. So I have 1/4 plugging in C1 plus 1/4 plus C3 equals 0. Therefore, C3 is going to be minus 1/2, right? Okay. So now what we can do is plug that back into the original equation. Unfortunately, none of our C's are, where's our equation? Here. Okay. Unfortunately, none of our C's are 0, so we're just gonna have to go the long way. So C3 is, well, C3 is minus 1/2, so minus 1/2 e to the minus t squared over 2. Wait, t squared over 2 minus 1 minus 1 1 plus t 1 minus 5 1 plus 1 0 0. That's going to be my x3 of t. My x2 of 2, and remember our solution is like the sum of x2, x1, and x3. So x2 is going to be, and I'm just looking at this. So x2 of t is going to be that part. C2, well, we've identified C2 to be 1/4. So 1/4 t, well, 1/4 e to the minus t. T minus 1 minus 1 1 plus 1 minus 5 1. Okay. And my x1 of t, sorry, I had no space at the bottom, so I had to jump back up, is C1, which is minus 1/4 e minus t minus 1 minus 1 1. Okay. So now that should net us in a good position to write our final solution. Okay, so I guess the quickest way to do this is, well, it's just algebra, but the quickest way to do this is to start with the less frequent terms. So t squared over 2 is the least frequent. So it's basically going to be, when you factor in, it's going to be t squared over 4 multiplied by minus 1, 1, 1. So therefore, for my t squared terms, I know I have minus t squared over 4 minus t squared over 4, t squared over 4. However, when I look at the answer choices, it seems that there is no t squared over 4. That's not really it's not really a big deal, because you could multiply, or you could multiply the entire equation by a number. So I'm gonna keep it as I'm gonna just keep it as divided by 4 here, but at the end we will probably multiply by something. So where was I? Okay, so what about our t's? Well, we have two t's. We have t over 4 multiplied by minus 1, 1 plus, where else do I have a t? Well, minus t over 1/2.
Move the paper down a little.
Sorry, what?
Can you move the paper down a little bit?
Can I do what? Sorry.
Move the paper
If I
down.
can-
It's,
Move
you
it.
were just two up. Yeah, there you go. Thank
Okay.
you.
Okay. Okay. So here I'm gonna have to multiply by 2t. Well, we're having a 1 second. Well, we're having a review session. So if you'd find like, because so I'm gonna be talking loudly, so it's not preferable, I guess, to stay here. But all right, sorry. Yeah, okay. Anyway, sorry. I was cut off. Someone else came into the room. Okay. So back to this. Well, I'm gonna have to multiply the first one. Yeah. So this is gonna be minus t over 4 minus t over 2. Well, the second term is gonna be minus t over 4 minus 5t over 2. The third term is going to be t over 4 minus t over 2.
Wouldn't it
And I'm
be
just
plus 5t over 2 because it's negative 1/2 and it's negative 5?
right. Okay, so now we have minus 3t over 4 is our top term. Second one's gonna be, is it 9t over 4?
Yes. Yeah, it's 9t over 4.
Okay.
Positive.
All right, and positive, okay. Second one is basically 1/4, take away 1/2, which should be just minus 1/4, right? So minus t over 1/4. Okay. So now we can look at our, just one more left to go. We can look at our like one term where there's no t. We have minus 1/4 minus 1 minus 1 1, and then we have plus 1/2 1 0 0 plus 1/4 1 minus 5 1. Okay, so this is going to be, well, so the top term is minus 1/4 plus 1/2. Wait a second. Plus 1/4 plus 1/2.
Isn't the top term minus 1/2 plus 1/4 plus 1/4, which is just 0?
I'm trying to Sorry, say that again. Sorry.
I was just saying, isn't the top term minus 1/2 plus 1/4 plus 1/4, which is just equivalent to 0?
Where are you getting the minus 1/2? Isn't it positive 1/2 since it's 1, 0, 0 for V3?
Because
is-
it's negative 1/2 times
It is
1.
negative 1/2. Yeah.
Oh yeah, gotcha.
And well, our second term is going to be 1/4. 1/4. Wait. 1/4 minus 5/4. That's gonna be just -1, right?
Yep.
Okay. Sorry, I'm a bit not doing the arithmetic as quick as I should be,
No, that's all right.
but -1. Well, that's 0. Okay. Okay. So if we go back here, we can see our ones term. So our one, okay, I'll write there. Our ones is going to be 0 minus 1, 0. Our twos is going, not twos, our t's, sorry. T's is going to be minus 3t over 4, 9t over 4, minus t over 4. And our t squared, well, our t squared term is basically minus t squared over 4, minus t squared over 4, and t squared over 4. So trying to look here at the answer choices because I feel like we made a mistake somewhere, but I'm trying to figure out where.
The t's term.
So our t, I think our t squareds are correct, but we messed up the t's.
But I think you did the arithmetic correctly. I just think the values, like the coefficient is wrong. And I don't know if that would matter if you use -2, -2, 2, and -1, -1.
What did you have as your starting V1 or V3?
That doesn't matter.
Well, it shouldn't matter, but it ends up you get the same answer, but it'll be in a different format. They
don't-
always start with V3 of 0, 0, 1. So
I
if you
I
don't
don't-
start with that one, you can get something a little different sometimes.
I don't.
So
Oh, sorry.
no, you keep going.
I don't think it's t squared over 2. I think it's just t squared.
Yeah, but isn't the answer choice A?
Yeah,
It is A.
and everything's t squared over 2. We have t squared over 4.
Yeah, that's easy. That can be like you can just multiply by 2, but for that you need a t term to go to t over 2, not 3t over 4.
Right.
Which means
So we made a mistake in our t's, definitely. So let's do the calculation again for the t's. And if we get it wrong this time as well, it just means I solved the linear system wrong. I hope that's not.
I mean, I
hope that's
solved it before you solved it, and I got the same thing.
Right.
Yeah,
so
I did as
it,
well.
So it means. Here, let's see.
I want to know what would happen if instead of using -1, 1, or the -1 for V2, or for, I think, yeah, V2 you use, or V1, you use the -2, 1.
It would be right. Well,
I don't know if that makes a difference.
I don't think it would.
Because I thought
I don't-
it might make a difference to the t value in the second x2 term. Because you're adding a 2. Yeah, it does actually, I think.
Yeah, I think it's -2, -2, t squared plus 1, -5, 1, t plus 1, 0, 0.
Wait, so you're saying when we solved
when we
when we
solve
solved
to get v1, leave it in terms of 2. Don't drop it to 1. Like don't like divide it by 2 at the end. Like if you're solving using chain, like go all the way to v1 and use that v1. Don't use your solved v1 from before.
right, but I want you to notice that, look, where does this make a difference? It makes a difference in, well, it makes a difference in our C's, but basically what happens is, suppose you had, well, if you wanted to have -2, 2, right? Then you would have, it's basically the same thing as 2 multiplied by C3, but 2 is also a constant, so it would be like embedded in the C3, if that makes, so like this is also, you know what I'm saying? They're mathematically
Yeah, you're saying it's
equivalent
already
statements.
taken into consideration because it's like, the only thing I could see is in your C3, you're multiplying it by, it would change your t squared over 2 value as well. I don't really know.
Yeah, I'm sorry for this one. I mean, we got our t's and t squared right in a sense, but I can't seem to figure out where we went wrong with the t's.
Did he upload a solution for like the earlier questions or no?
No,
No,
I talked to him. He said it was on purpose.
On purpose?
Yeah, he said the old ones are pretty simple and straightforward,
yeah, I mean,
which they are, I guess, but a
We're
refresher
stuck.
would be nice.
Yeah, I mean, like, I don't think that's an excuse, to be honest. It's kind of a game excuse.
Yeah, I guess.
so
It's not
if
much
we
we
have,
could do about it though.
right, so if we have, let me just try something. If we have t here and I have no, doesn't work. So yeah, I either made a mistake in solving for the C's.
I mean, I can double check that. I can just use a calculator to solve for that.
Okay. Or yeah, let me know what you get for your C1, C2, and C3. If they are correct, then the
Okay,
only second.
for my t squared term, I got let's see. Wait a minute. No, I didn't. Ay, caramba.
I think I might have figured something out. I think in our original equation, we actually have it wrong, or not the original vector, because it's should be 0. Wait, never mind. Since the eigenvalue is -1. So it is right.
So we have 2 ways to go here. Do you guys want to? Oh, I see my thing is frozen. Not really sure how to. Okay. We have 2 things to do here. I could either resolve this,
I think we should
or
just move on.
or
It's
just
like,
move on. Yeah.
We can move
Because-
on and do it later.
I think we got the point across that, you know, when
like
you had,
this is, we can do this
Question number-
later. Like when we go back to
Okay.
number 2, we can also go back to number 5.
5.
But yeah, when I
okay.
use the calculator to find the coefficients, I got -4, 1/4, and -1/2, which is what we got as well. So
Wait, say that again.
the
I just wanna-
coefficient for C1, I got -1/4. For C2, I got 1/4, and for C3, I got -1/2. So it's the
The
same.
same
There we go.
thing.
Okay,
Yeah.
so it's the same thing. Okay. So it was a calculation error after we plugged in the C's.
Yeah, it wasn't something like, it was just the setup was wrong, maybe, or something like that. Like,
Okay. So for this question, I'm going to be switching the view to the, what's it called? I'm going to be sharing screen, I guess that's what it's called. Yeah, I'll be sharing the screen because it would be a bit hard to explain otherwise. But so share screen. There we go. Can you all see the question number 6?
yeah, I can see it.
Okay, so question number 6, which system has this phase portrait? So I guess what I can say about this question is that those are non-linear systems. So a linear system would be something that you can write in, it would be something that you can write. It would be something that you can write in the form of, you know, the form that we've been writing with like x prime equals a coefficient matrix where there's only constants multiplied by x1, x2, x3. Am I making sense, or do I need to make that clear?
Can you repeat that again, maybe?
Okay, so the eigenvalue method we've been using. So now I've switched over to writing on the notebook. So try to navigate to that or pin it. I don't know, because like I can't draw on the question. So a linear, well, the way we've been solving it is we've said that x1, x2 prime is going to equal to a, b, c, d. Right. So can you all see this form?
I got you.
So this is the linear homogeneous form, because if you subtract this from this side, then you get equals 0. That makes it linear homogeneous. So
right.
And these have a set way of solving it, like the eigenvalue method. As for those systems, such as shown in question 6, they have, as you can see, they have more than one node, if you know what I mean. Can you see that like there are 2 nodes?
Yeah, it's like the spiral and then the cross, right?
Right. So nonlinear systems can have more than one node, and what's important is that the location of the nodes, it happens to be when x1, x2 prime. So when the derivatives are 0, that's when you have nodes, and that should make sense because that's when it looks like a linear system. So are we getting that?
Yeah.
Could you repeat that one more time? Sorry, the wording, I
Okay.
just kind of lost you.
It kind of just went through my head.
Right. So when we have a nonlinear system, you get a node. I call them nodes. I don't know what they're actually called. You get a node. You see like this and this.
Yep.
When x prime equals y prime equals 0.
Okay, yeah.
All right. And that should be intuitive, because if that was equal to 0, then it looks like a linear homogeneous system. Then the nonlinear system would look like a homogeneous linear system at that point. It would have a similar behavior, I guess that's what we call it. So I don't know how much your professors cover this, but actually like the book goes into more detail about like the stability of these systems. And there's 2 sections. There's almost linear systems, where you have like an additional variable, or there's completely non-linear systems. So I don't know how much your certain professor is going over this, but I can say that the most important part is knowing that x prime equal y prime equal 0 is going to give you the node. So the way to solve this question is first to figure out the location of the nodes. So I'm gonna go back. Is it harder for you guys to see my notebook when I'm sharing my screen?
Not really. You can like do something where you can view side by side and then pin like your screen and it works.
Okay. So if we look at the number 6, I cannot look at both at the same time. So some of you may have to help me with this, but can I get like an estimate of the coordinates in X, Y, where the nodes are? So let's start with the spiral on the.
Yeah, the left node is at like -2x, +1y, roughly around there. And
Okay.
the second node is roughly at like 2x. And then it's somewhere between like 0 and -1y, something like that. So I would say
-0.5.
yeah, like it's not exactly. You can go with 0. You can go with -1.
Let's call it 0.3. The Y.
Sounds like a plan.
So
As a negative 0.3.
Yeah,
negative
like
0.3.
kind of arbitrary.
Does that?
I've done this one before, and I can tell you the actual coordinate of the spiral, the y coordinate, is about 1/3, either 1/3 or 2/3. It's not 1. It's much lower.
Okay. Thank you for that. So it is 1/3. Okay. So we have the coordinates now. Can you guys see the coordinates of the points?
Yeah.
Okay. So what we need to find is when you plug those two numbers in, x prime equals 0. So let's look at I'm going to start from E because we know A is the answer, so I don't want to. Or is A? Okay, I don't know. Let's look at E. When we look at E, you have 2x minus 2y minus 4 equals x prime. So x prime equals 2x minus 2y minus 4. What I'm going to do is I'm going to plug in what's easier to, well, I'm going to plug in the -2. Let's call this one A. I'm going to call this one B. I'm going to plug in point A. So point A is going to be -4 minus 2/3 minus 4. That is not 0, so it's not E. Let's look at D. Well, you're supposed to get x prime equals 0. That's the point, okay? So D.
Only x or both x and y?
Both x prime and y prime.
Okay.
But so if one of them isn't, then it's not the solution. So D is x prime equals x minus 2y plus 3. Plugging it in again, there is no way that is there. Let's check. -2 sorry, I'm a bit blanking. -2 minus 2/3 plus 3. That is not 0, right? Yeah. Okay. It's not D. Let's look at C. X prime equals 2 minus 4x minus 15y. So I'm gonna plug the numbers in again. It's gonna be 2 plus 8 minus 5. That's also not 0. Pretty close though. No, it's not close. What am I saying? Okay. B. X prime equals 2x minus y. It cannot be 0, obviously. So -4 minus 1/3 equals is that -13/3? Yeah, not 0. Let's look at A. We have 1 x prime equals 1 minus y. Wait, 1 minus y squared. So if I plug in, wait, that's not 0 either. Wait a second. Something's off.
Maybe
Is
for
it
the first
possible-
one, I would say it's closer to 1 than 1/3, since it's divided in twos. The y
The
coordinate.
Yeah. Sorry, what do you say about the first one again? That it's closer to
Like-
0?
No, that instead of 1/3, it's closer to 1, since it's like the coordinates are divided into twos. I think
Yeah.
that works out
It would
better.
have to be 1. And then x plus 2y would be -2 plus 2.
Right. So we have the coordinates wrong. Is that what you're saying?
Yeah, I think the coordinate for y for the first node on the left should be 1.
Okay. I'll try to do that again then. If we look at, okay, so then the first one would be 1 minus 1. That works. The second one would be
You know, they should really give us the coordinates on the exam.
yeah. The second, okay, so that works. So I guess the coordinates of the second one are 2 minus 1.
Yeah. I'm thinking that as well.
Okay, so I guess
That's kind of
I don't know what to say, but I'm glad like we got that.
yeah.
I'm glad
We
were
only
able
got
to-
there because like we knew the answer is A, so you gotta just like kind of.
But yeah.
I don't
to
know.
be
I feel
fair,
like if. Sorry, you
Sorry.
go.
You have to check both points, or do you just check one?
You should check both, honestly.
you
but
should
like,
check both.
because it's both derivatives, x and y derivatives.
I could be completely wrong, but it also looks like the phase portrait is kind of drawn wrong because like where the slope field is 0, like where the slope kind of goes towards 0, it looks like it's above that point. I mean, I could be
Okay.
wrong, but
So can I want to correct something. So where yeah, no, actually, wait a second. In a face portrait, you graph x prime, y prime. Wait, no, you know what, you are actually right, because those lines are not or the trajectories are dy dx, but the lines are actually y prime x prime. So it is where where you said the slope looks like it's 0.
yeah,
It is actually that, you are correct. Okay,
that'd be the
so
same for the second one as well. Yeah. Okay, cool.
Right. So you want to move on to question 7?
Yeah, I mean it's pretty easy as long as you can like eyeball like the nodes and then you kind of just plug and chug and find which one is 0 for both x prime and y prime. You're chilling. Like,
I also feel like they will have to give you clarifications like, hey, where are these located? I feel like they have to tell you if it's not clear enough.
Yeah, you have the right to like ask your professor, and he won't have
I
a
don't know.
problem.
Menezes will tell us though. He might.
Okay. He might be like, look at where whatever. He's a nice professor. He's a nice professor.
I like him.
Anyway,
I don't
yeah.
think he's coming next year, is he? He was not on
This
the
is
list.
last semester.
This is
Oh,
my last semester of math, so it doesn't matter.
true.
It's okay. It's his last semester teaching or
Here, I think.
at Purdue.
That's
Yeah.
what I've heard. It's his last semester here at Purdue. I don't know what he's going to do afterwards, but
What a shame. Okay. Anyways, do you all want to move to number 7?
Yeah.
yes.
So question is asking which of them for which values of A is the equilibrium solution a saddle point? So it's asking what values of A make this a saddle point. Do you all remember what the eigenvalues for a saddle point are?
There's one at less than 0 and one at positive. So one negative.
One positive, one negative. Yes. So let's go ahead and compute.
Oh, it looks like we're gonna have to memorize phase portraits.
I feel like saddle is an important one to memorize, and it's not that hard to like know about it.
Yeah. They're just too different.
Yeah.
And saddle point, it only like the phase portraits are only for 2x2 matrices, right?
I'm not sure. The saddle point is the only one I have memorized.
They are only for 2x2s. Otherwise, it would be like 3D and then you have a portrait.
Correct.
That stuck.
Yes. Okay, so a squared, so eigenvalue would be, what am I doing? It would be a minus the squared, take away -1, that's +1, equal to 0. And I'm just trying to figure the logic of the solution. Does this look right for the characteristic equation? Because sometimes I just...
Yeah.
Yeah, that makes
Okay.
sense to me.
Okay, well,
Doesn't really give us any information though.
it does. I'm just trying to figure out a way of how to phrase it because
The way I
Yeah.
automatically look at this, I would just plug and chug. I would try one that's
fair enough.
in between,
Right.
and then I would just try all of them, which would take a while. But
So I guess here, so I'm just gonna do it like this. You guys are free to interpret it the way you want. Is that like there's
makes
no
sense.
other way I could mathematically demonstrate. But
I mean, the way I saw it was like the right side has to equal, because like you're only changing a, so the -1 and 1 are going to be there no matter what. So the right side has to be -1 and the left side has to be something squared. And
Right.
since you can't have a positive number equal to an imaginary,
there
it
you
can't
go.
be
Yep,
any
yep.
value of a.
So does this so are you all aware of how to interpret this, or do I continue?
What's the definition of saddle point again?
One positive, one negative eigenvalue.
I mean, it makes sense that it's no values of a because a minus lambda
Yeah,
is an
because
imaginary
this-
number.
This is always so if a is 0, this is going to be a center. If a is greater than 0, this is going to be a spiral.
Yeah, and if there's imaginary numbers, it can't be a saddle point, essentially.
Exactly. Yeah, so no values of a. Okay, next question. I'm not gonna write anything on the paper here because number 8 I think it's the easiest question on the practice exam. Okay, number 8, starting from x of 0 equals to 1, y of 0 equals to 1. In which of those models does x of t, does it actually say converge?
yeah,
So how does it, okay, converge to infinity, that doesn't really mean anything. It just means it expands indefinitely. It's not, that's not converging, that's the opposite. But anyways, as t approaches infinity, so what you can see, okay, so does the answer not pop up to anyone specifically, like or like ask me questions, why is it a, I guess, like why is it not, no, you want me to do them like one by one with,
Could you
so
just
why
go
is
through
it,
the thought process?
okay, so why is it not e, for example? Why is it not e? Why can't it be e?
Because
Well,
the negative x. Oh, sorry. You're explaining. Continue.
you can go ahead. Maybe you have a better way of saying it. It's an open discussion, you know. You can just unmute and talk.
It's all good. I was just gonna say they're negatives, so it doesn't.
Basically,
Yeah.
yeah. If you look at x prime, for a positive value of x and a positive product xy, then x prime is going to be a negative value. So it doesn't really help. And now, how did I know x and y are supposed to be positive? Well, that's the initial condition.
Okay.
Okay.
So
So why is
so
it-
we're plugging in 1 for x and y.
and checking what, yeah. Well, you
And
want to,
so-
that will give you the rate of change at that point, but you want to look more so like at the general, what does it mean? So the book actually goes into detail how you could tell. So I actually forgot how I could tell if it's like a predator-prey relationship or symbiotic relationship. I forgot like the names, but like one like where they help each other, the other one's where they eat each other. I forgot, but
And then there's a
I mean,
competitive one.
there's competitive. I forgot like the details, but
I'm pretty sure the way to tell is by the XY term. If they're both negative, they're competing. If they're both positive, it's symbiotic. If one is positive and one is negative, the one with the positive is predation.
Can you say that one more time?
So you tend to look at, you can tell by the XY term what their relationship is. If both XY terms are positive, then you have symbiosis. If both XY terms are negative, then you have a competition. And if one is positive and one is negative, then you have predation.
Okay, so you're saying not the x and y itself, but like, so for part A, they're both positive, so x and y are both positive. So you're saying that it's going to be symbiotic?
Yes.
Okay.
all right, yeah. So I guess I'm a write that down, but unfortunately I should have reviewed this before the review, but I forgot. So if XY term, so if
I
I'll
have a
write this
pretty
more
good
down.
I have a pretty good explanation in my notes. I can kind of post that in the group if you guys want.
Yeah, if you don't mind, that would be cool.
Yeah, sure.
So I'm just writing it down for x prime equals axy plus bx, and y prime equals alpha xy plus beta y. Then if well, if a and alpha are opposite sign, then that would be what was it? Predation.
If they're opposite sign, yeah.
The xy, okay. And if they're same sign, then that would be oh crap. Can you hear me?
Yeah.
Okay, because
Yeah, so basically if in both equations, if the coefficient of xy is, if that product is greater than 0, that means they're either in competition or cooperation. And if the product is negative, that means it's predator prey.
wait, if they're both negative, is it
If they're both negative, that means without each other, like they then it kind of depends on the value of x and just y. Let me just post my notes. It might be easier than me speaking.
okay? I could. Well, since we stopped here, might as well just present like the entire theory behind it. So
Yeah, I put my notes into the group me. I don't know if that's gonna help.
Yeah,
So-
they look pretty good. I was just reading over them. They seem to help, or they help me
Okay.
at least.
okay. So if we have notes in the grouping, then it should be fine. But
I also put this site I was looking at in the chat. This one helps a lot.
that's the same side time I happen to be on.
Yeah,
Okay.
it was the first Google results. That's no surprise.
Okay. So all of us are lazy, I guess is what it means. So do you want to go over the question one more time with applying that specifically? Or do you want to move?
I'm
to the
okay if we
next
move on, since it's pretty, that's kind of like a, we need to memorize on our own type of thing. And for the question, I
okay.
feel like it's pretty obvious with the negatives.
Right.
Yeah.
Yeah.
And especially if you look at the examples in the second page of my notes, it's pretty easy to understand.
Okay. We transition now to Laplace transforms.
Hold on, I need to pull up the table.
So exactly is what I was gonna say. We all need to pull up our
Where can we find his?
Table.
Yeah, his table.
They're all low key, all kind of the same.
Oh wait. Okay, I actually have my second exam with me, so I could just look at the table on there. Actually, it's not on here. Never mind.
Must have ripped it out.
I did rip it out. That's sad. Wait, I think you could pull it up on
He uploaded the like past exams on Brightspace, so you might be there.
yeah. That's where I was. It is there.
okay. Do you all pull up your Laplace tables? Because unfortunately I cannot pull it up for everyone. Like if I pull it up for everyone, then we can't see the question.
Yeah, no, pull up your own Laplace table.
Yeah, I have mine up.
Okay. So question number 9.
Yeah.
So are you all okay with starting? Because we kind of took a bit of a break
Yeah.
and slow progress. Okay. Okay. So find the Laplace transform of the function whose graph is drawn below. Okay. So, well, what you need to do is first define what that function is algebraically. And I think we can all see that you need the step function for this, right?
Yeah.
So we can have a function that turns on at 1. Or wait, a function that turns on at 1.
Yep. And then
Wait.
then it goes down at 2.
Right. So we want a function that turns on at no wait a second. Want a function that turns on at 1 and turns off at 2, right?
Yeah.
Is that correct?
Yes, yeah.
Okay. Then
You want U1, right?
right.
So
So
would it be U1 times 1 minus U2?
yes.
Okay.
Is this correct? So just checking with everyone before we proceed.
We can't see it right now.
Oh, really?
Yeah.
Let's see. Okay. So U1 minus U2.
U1 minus U2?
Mm-hmm.
But yeah, that makes more sense than what I have.
Is it U1 minus U2? Are we all in agreement?
Yep.
Okay. So then I guess the next step would be to just perform the Laplace transform on both sides. So if we do that, and the relevant transform from the table is going to be, well, you want the transform of the step function. So just looking for the, there we go. So the Laplace transform of ut minus c, which is the same thing as the Laplace transform of u at c, well, that's just going to be e to the minus cs over s. Okay, so
sometimes I have, sorry if I'm interrupting, I'll let you finish if you're done.
I'm finished. You can say what you were.
Okay, so sometimes I have trouble with the step functions on making my
Platform
equation,
function.
On making the actual algebraic function. After that, I'm fine usually, but it's just the making of it that I have trouble with occasionally.
Okay, so I can give you a really good tip on that because I also once struggled. So the way you want to make your step function is first make it, as silly as that sounds, you have to first make it with words, and then you can, and then it becomes pretty simple. So if we go back here, we can, tell me what this function is in words.
It's a function that's equal at 1 between 1 and 2.
That's the math way. Say it as if you were describing it using like just normal language. When does it turn on? Think of switching.
Okay, it turns on at 1, turns off at 2.
Bingo, that's it. So we look here. What's something that turns on at 1?
U of 1.
Okay, what's something that turns off at 2?
Negative U of 2.
There you
Okay. Okay, that makes a lot of sense.
You can also think of it as, you can draw both functions if you have pens of different color. I don't have on me right now, so I can't show you, unfortunately. You can do that too.
Did someone ask how you guys like define the function as u1 minus whatever it was?
Yes.
You can't really see what's written. It's really blurry, but what is a function you guys defined it as?
Is it still, is it still blurry for you?
It's still blurry, but I'm able to make it out.
Yeah, as long as you just say it, I can like kind of write it down at least.
They got, we said it was U1 minus U2.
Okay. Gotcha. Okay, that makes sense. Yeah.
Okay, so I just realized I was unmuted. So there you go, that's your answer. Any questions?
I think I'm just stupid, but why is it U1 minus U2? Like I don't really remember I don't really know what I'm looking at. I've done Laplace Transform in 2 classes, but I don't really know what I'm looking at.
Do you know what U1 means?
No.
So U1 means that it equals 1 at starting at 1. So at t equals 1, it equals 1. And U2 means at t equals 2, it equals 1. So if you subtract U1 by U2, it turns on at 1, then turns off at 2. So you'll just have a line segment between 1 and 2.
Gotcha.
It's like basically a heave side function has a value of 1 whenever it's a function of 0 or more. So like if you take u of 0, it's equal to 1. And u of anything above 0 is also equal to 1. But anything less is 0.
Gotcha.
And like, for example, if that like, if it dropped from 2, 1 to 2, -1, it would be minus 2 U2, right?
Yeah.
Okay.
What was that you just said?
So I'm saying, you see how like it's stepped, the step goes down by 1 unit back from 2, 1 to 2, 0. I was saying if it goes down from 2, 1 to 2, -1, the function would be U1 minus 2 U2. Because
Did you say -1 or -2?
-1. It goes down 2 units, which would bring
Yeah.
it down to -1.
So the coefficient in front of U2 would become -2, not -1.
Yeah.
Okay, got it. And the same thing if like it went up to like 2, 1 instead of 1, 1, it would be 2 U1.
And then how would that translate to the Laplace transform?
Well, then you would pull out a 2, right? So the 2 would be your like just your constant you pull out. So it'd be 2e to the negative s over s minus 2e to the negative 2s over s.
Gotcha.
All right. Should we move on?
Yeah. I think this is easy.
I think you might still be muted if you're talking to us. Sorry.
So we're on question number 10 now. Hopefully got any doubts with number 9 got cleared. So number 10. Okay, number 10. I don't know why it's so blurry. Like for me, it's not. It's like crystal sharp, but
Yeah, maybe it's like the bandwidth of the internet, like where you are.
I mean, I can zoom in. Does it help if I zoom in, or is like
Yeah,
does
it
it not?
actually does.
It actually does.
At least like if it's blurry, it's a little bit easier to like comprehend the blurriness.
So is this zoom level better?
Yeah, that's fine.
Okay. So number 10. Y prime is equal to y minus 4e to the minus d. And the initial
It's
condition.
blurry now.
How'd that happen?
I don't know.
Now?
Yeah, it might be trying to focus in too specifically. I don't know if that makes sense, but if you zoom it in too far, it might have trouble focusing on what to like focus on.
Maybe a way to shut off the autofocus too. If you're
How
on
do
the
you?
school.
Yeah, I'm trying to figure out how do you even do that. I mean, are you all able to see right now, or is it still blurry? Or
I'm able to comprehend it.
Yeah, it's fine for me.
okay. Yeah, I'm sorry about that. I actually lost my graphics tablet pen like this morning, so that's what I was planning on using. So
Sorry.
unfortunately, okay. Shall we go on?
Really appreciate it. Yeah.
Okay. So y prime equals y minus 4e to the minus d, y of 0 equals 1. For differential equations to be solved using Laplace transforms, the method is usually to take the transform of both sides. So the transform of y prime, and correct me if I'm wrong, is s y where capital Y denotes the transform. So sy of s minus minus y prime at 0. Wait, minus y of 0, not y prime. Minus y of 0 is equal to y of s minus 4, and then the transform of e to the minus t is going to be 1 over s plus 1. Wait, is that correct? Did I make a mistake somewhere? Okay. So then, okay, so that plugging that in, it's sy of s minus 1 equals y of s minus 4 over s plus 1. And then sy of s minus y of s is equal to 1 minus 4 over s plus 1. That means y of s is going, it's what factoring out y of s is going to be s minus 1 equals to, let's just group this together. So that's just going to be over s plus 1. You're going to have s plus 1 minus 4. Hold on a second. I feel like something's not right. But that would give us this, but I think I've made a mistake somewhere. S plus 1 minus 4 is s minus 3. Oh, it is correct. Okay.
Yeah, it looks correct because then you divide, then you get the answer.
Yeah. Okay. Any questions? I think this one was pretty straightforward.
Oh, and then you don't even have to go backwards. You're just chilling. Okay.
No questions, I assume.
No questions here. I'm just trying to remember what happens when it's a double prime again, like with like say you had a double prime of y.
Oh yeah.
Do you remember what
Then it
happened
becomes-
specifically?
They will give you the table. You don't need to memorize that. They
Well,
will not.
Well, that one's not specifically in the table. They just have a single prime in the table.
Really?
Yeah.
Okay, so then they expect you to know the pattern.
Yeah, we do need to know the pattern.
Yeah,
Okay.
I just forget the pattern and I can look it up, but you know, now that we're here.
Well, if I see the pattern, I might remember the way I used. Like I would. Okay.
I
So
think
give me
the pattern is so it's going to be as if it's f double prime, I think it's still going to be, I don't know. Actually, never mind. I don't know. Sorry.
Is it sy of 0 or?
I can let you know real quick. I think I have that written down too.
So if it's f double prime of t is going to be s squared f of s
Yeah,
minus
I got it.
Okay.
Yep. So it's the same way I've written it.
Okay, yeah, that makes sense. We can move on. Sorry for holding up.
No, so the pattern is so here's the thing. That's how I figured it out without looking at the table. The pattern is actually, well, you're gonna know the first one, right?
Yeah.
So you're gonna know this one. So when you look at this one, the thing that should pop out is it's s times y of s but then like the term to the right goes to the lower power of s, which would be s to the power of 0, which would just be 1. So this is actually just s to the power of 0 times y of 0.
What's the last thing you have? Minus y prime. Okay.
Minus y prime of 0, yeah. So the pattern is just you take the number of primes is your number of s's that are not raised to the power of 0. So if you have 1 prime, I have 1 s. So if I have 1 s, is going to be s times y of s. And then remember that this should be enough to solve a first order differential equation. So you only know y of 0. You don't know y prime of 0 in like a regular IVP, right? For first order. So it's just going to be sy of s minus y of 0. Now for the second one, remember the rule is the number of primes is the number of s raised to a non-zero power. So if I have y double prime, then it's going to be s squared y of s. Now what's my next term going to be? Well, it's the same thing as before, but now I have an s raised to 1 here. So it's just going to be s. And after that, I need
it's just distributing. I think you should write it out where you like
n,
kind of
using
pull out
n.
the s from the first two terms. That might make
So,
it easier to understand.
You
It's
mean like
basically
this?
s times the y prime 1 minus y prime of 0.
You mean, yeah.
Oh, you're writing a general formula.
I mean, it keeps going. Like, if I go to the right, it would be like s to the n minus 2 y prime and so on. So it would be like s n minus 2 y prime of 0. And you got the point. So yeah, I guess I was just trying to say that to memorize it, to remember the pattern, it's just s squared. Like the number that s is raised to is the number of primes. And then as you go to the right, it keeps going down by 1 every time, if that makes sense. But yeah. Okay, so number 11. And we have taken our time, I guess, looking at the clock. Does anyone? Yes, we've lost. We started at 16, now we're at 14. No wonder. Well, we've been taking quite a bit of time, but that's fine. So y prime prime. Let me know if you can't see again. I know our focus with the camera is killing us, but minus 3y prime of t plus 2y of t equals delta function at t, y of 0 equals 0, y prime of 0 equal 1. So I guess there's no surprises with this one. I'm trying to figure out where someone might. Okay, so we'll go over it. I guess it's not. So if I Laplace transform this one, then I'm gonna have s squared. I took it for both sides, so I'm gonna have s squared. Okay, I'm gonna have s squared y of s minus. That's gonna go to 0. So, and I know you can't see the rightmost side, but it's just Laplace. So here, I'll just write like this. Okay. So if we factor out y of s, we have s squared. Oh, I see. Okay. So the trick with this question is we're gonna need to do complete the square later. But minus 3s plus 2. And please someone correct me if I'm wrong, because if we're like wrong at the beginning, we're going to mess up as we go forward. Y prime of 0 is minus 1. And so that minus 1 equals the Laplace transform of the delta function at 2. The transform of the delta function is e to the minus cs. So that's going to be e to the minus 2s. So adding 1 to both sides. Let's add 1. Okay. Are we clear up to this point?
Yep.
Yes.
Yep.
Okay.
Oh wait, quick question. What is that function on the left side? I don't
Right, you mean.
remember. On the right, sorry.
Okay.
Delta 2. Like I know what it
Right.
is on the Laplace table. I just don't know what it is like graphically.
So
Yep, I can see it.
delta function. Okay. Delta function is just the delta function at some value c. Just means that if I have c minus some value a and c plus a, and I have something like this, all it means is that the delta function would mean like if you take the limit. Okay, no, sorry. So it just means that the area of this is going to be 1. Yeah, the area of this is going to be 1. And if you take the limit as a approaches 0, so as a approaches 0, can you see what happens? Like it gets thinner and thinner, and it spikes like higher.
Oh, okay. Yeah.
That's what I'm trying to show. It's better to like use a computer to show the animation. But basically, if you take as the bar goes up and up and up and up, as you decrease a to infinity, the bar becomes much thinner, and as the bar becomes much thinner, for the area to stay constant, it has to rise up, so it keeps going up. So it's like one spike at one point, you know what I mean? So it would be like, so delta, if we graph like delta at c, is just it probably looks like this.
Oh, okay.
Not exactly like this, but you know what I mean? It's like
Yeah.
as a, yeah. So
As
it's like
it gets closer to zero, he'll
Right.
look more like a vertical line.
Right. That's what the delta function is. And the important part is that the area is 1. Okay, that's very important. The area is 1. Okay, so if I have 2 multiplied by that, the area is 2. Is that clear?
Yeah.
Okay. Yeah, that's very important, and they could ask so many questions, but just knowing that the area is 1 will help you like bypass any kind of trick or something.
So the area is just going to be C.
If I have C, no, C is like where it is.
Okay, the area is just going to be always
If
1.
I had like A multiplied by delta C, like del at C, it means the area is going to be A.
Okay, I see.
Yeah. So do we want to go back to the question?
Yeah, sorry.
No, it's fine. That's a fair question. It's kind of a weird function, like. So looking at this, well, basically looking at this, you know that y is equal to the inverse Laplace of capital Y of s, which is equal to the e minus 2s plus 1 over s squared minus 3s plus 2, correct?
Mm-hmm.
So our mission is to find, it's inverse Laplace of this. So our mission is to find this because the y is going to equal to the inverse Laplace. Oh, you can't see again. Y is equal to, yeah, you cannot see. Can you see now?
Yeah, it actually looks better then.
Okay. Is e to the minus 2s over s squared minus 3s plus 2. So we break this down into the transform of e to the minus 2s divided by the mess plus 1 over the mess, okay? If you know about Laplace transforms, it should be clear that knowing the inverse Laplace of 1 over the mess is going to be easier than e minus 2s over that. So I'm going to start with finding this. This is one part of the solution. And this is actually the only like tricky part in the entire question. So up to now, it's just been plug and chug. This, well, what two numbers add up to -3 and multiply to 2?
-2, -1.
-2, -1. Wait, is that true?
Yeah.
Yeah,
S minus 1, S minus 2.
he's right.
Okay, well, trying to figure out if we did something wrong because. Okay, so well, you could factor it. Or okay, so you could factor it like that. But the reason why that won't work is because, well, it would work, but in an exam setting, it would be the wrong choice because then it would be a product of two transforms, and to inverse that, you need to apply the convolution rule. You all remember that?
Can you not do like the A over S minus 1 plus B over S minus 2?
Partial fractions, you mean?
Yeah.
You can do partial fractions. That will work. Do we want to do partial fractions, or do we want to complete this square and then it will turn into like a trigonometric function? Then you could. So we could do it either way. What do you guys want to do?
I'm more comfortable with partials, to be honest.
Partial fractions?
Yeah.
Okay.
I kind of like the other way, but I can always get more comfortable with partial if we want to do it that way.
Okay.
Yeah.
Like it doesn't
seems-
actually.
So it
I
seems like
just-
we're going to proceed with partial fraction decomposition. So this becomes the inverse Laplace of 1 over s. Wait, no, it can't be minus. It can't be plus, sorry, because there's going to be s minus 2. S. Oh, God.
It's s minus 2, s minus 1, right?
Yeah. So we can break that down into.
It's 1 is equal to a over s minus 1 plus b over s minus 2.
You want to do it? Okay. A over s minus 1 plus b over s
Oh, you're doing
minus 2.
2 before, I didn't see.
Okay. So it doesn't really make a difference. So then well, then it would be a s minus 2 plus b s minus 1.
Wait a minute. How did you get rid of the e to the -2s?
We just
So I still didn't do that. I separated into this, and then
Oh,
that
okay, I see.
that inverse becomes much easier when you know the inverse of that.
Yeah, no, that makes some more sense.
Okay.
then
So
here we just set s equals 2, s equals 1.
so if we do it with partial fractions like this, well, this is true for any value of s. So if s was, say, 2,
Yeah.
then the a term would go to 0, and then the b would be 1/2, right?
1/2.
Is it not?
I think it would just be 1.
Yeah, it would be 1. Because you just look at that expression b times
1 equals 1.
equals 1.
My bad.
And then for s is equal to 1, you're going to get rid of the b term, and you'll get a times -1 is equal to 1. So a is -1.
Okay. So now it's going to be the transform of. So the inverse transform of 1 over s minus 2 s minus 1 is going to be, well, it's going to be the inverse transform of a over s minus 1. So 1 over s minus 1 plus
Can you move
1
it down a
over
bit?
s.
Sorry.
Okay, is that bottom line? Can you all see the bottom line? Does that make sense?
Yeah, makes sense.
Okay. I'm just gonna copy that. Is that correct? Just give me a second.
Yeah, that looks correct. That's what I got too.
Okay, because I'm doing this without a table, so I have to like.
Yeah, that's correct, because it's 1 over s minus a is the transform for e to the at. So this
Right.
like if you're subtracting 1, it's e to the t. So that is correct.
Okay, good. Okay, so we got one part. The second part is then so that part is going to be, well, it's going to be, well, I need a
Honestly,
table for that one. I'm not going to be able to do this without a table. So-
In an exam, you can probably stop here, because you know that you're computing y of 1, right? And so you're gonna put in 1 for t, so it's gonna be minus e. And the only answer choice with minus e is a.
Yeah, but
Say
we
that
still,
again.
So you know how you did the inverse transform to get e to the negative e to the t plus e to the 2t, right? So this
Right.
is actually some part of y, and you're computing y of 1, right? So if you put in t equals 1, you're gonna get something with negative e, right? And the only answer choice with negative e is a. So you can if you
Right,
want,
but
if
maybe
you're on less
there's
than
like
time.
a plus e or something in the other part of the solution.
Yeah, but like if you're stuck on time, like this.
If
might
you're
be-
stuck on time,
Yeah.
yeah, I'd say that's brilliant. Good catch.
but what about the e to the minus 2s part?
Yeah, I'm still doing. I have
okay.
not computed that
Oh,
yet.
okay.
This should be a
So-
similar process, shouldn't it be?
It would be. I'm just trying to find the formula on my table. Once I do, it would be. Oh, I found it. So, e to the minus c. Yeah.
It's
So
isn't
that's
that
just gonna.
step function?
So that's gonna be. It's gonna be minus e.
Oh.
Yeah, t minus. Is that right? It's e. multiplied by okay. Therefore, is the answer. Wait a sec. Wait, is oh wait a second. It's minus e to the t plus e to the 2t. So it's gonna be minus e to the 1 plus e to the 2. Okay.
Where did you get the? Can you explain how you got the L
How I
or
got
the
the
third line or the second line,
sec
the one with the U2?
okay. If you take the, can you see here so I can write here?
Yeah, a little bit. Yeah, I can.
Okay. So the basic idea is, suppose I need to take the inverse transform of e to the minus cs multiplied, and listen to this, multiplied by a function that I know the inverse, like I know what the original function is.
Okay.
Just like in this case, right? I know what, then that's just gonna be, well, that's just gonna be the step function at c multiplied by f of t minus c. Okay.
Okay, so e to the negative. Okay, yeah. I see that.
How do you know that your step function when equated at 1 goes to 0? Like the u2 times negative e to the power, all that stuff. How do you know that goes to 0?
Because it's by definition, the function turns on at 2. So it's 0 everywhere else.
Oh, right. Okay, correct.
What
Any more
happened to
questions?
like the one we had? Wasn't there a +1 earlier in the initial
Yeah,
transformation?
I did
No,
both.
that's f. That's like,
So what we did, so this is a explanatory mistake on my part. What you're saying here is basically we needed to find, where's this? Trying to find, yeah, basically we substituted the derivative transform formulas and we isolated y of s, and at the end we needed to find the inverse transform of 1 plus e to the minus 2s over s squared minus 3s plus 2, right? So basically what I did is, this thing is the same thing as 1 plus e to the minus 2s over s minus 2s minus 1. But then this thing is also equal to the inverse transform.
I see where we're going with this.
Yeah.
You're good.
Yep, got it.
So
Thank you.
if they were asking for y at 2, would it then be e or 2 times the quantity e minus, or would it be 2 times e to the 4t minus 2 e to the 2? If it was asking for y equals at 2?
Well, at y equals 2, you would lose the exponential, right?
I would lose the exponential.
Yeah. Because at y equals 2, your t minus 2 becomes
Oh, t
0.
minus a. I forgot the minus a part.
Yeah.
Okay, I see.
So it would actually be e squared plus e to the power of 4, right? No, minus e squared plus e to the power of 4,
Okay, I see.
right?
Yep.
Okay. Any more questions before we move on to the next one? Any more questions before we move on to the next one? No?
I think we're good. Thank you.
Okay. Yeah, because I cannot. Okay. All right. So no more. Okay. So moving on to question 12. Can everyone go to question 12? So we're all on the same page. Go to question 12. So from the answer choices, you're already going to see that there. Can you all see that there's like an integral and it's the convolution formula?
Yep.
Okay. So same process as before. Let's write the differential equation down. Y prime prime plus 4y is equal to some function g. Additionally, we know y of 0 is equal to a, and y prime of 0 is equal to b. Now, what we need to do is take the Laplace transform of both sides. As I said, that's your strategy. Solving differential equation, that's your strategy. Take Laplace transform both sides. It's going to be your first step. I can almost bet on that. So if you take the Laplace transform of both sides, then what you're going to get is s squared y of s. And here I'm just applying the formula for the transform of the second derivative, I guess. So,
Welcome back.
plus 4 multiplied by the transform of y. Now I know that the transform of y is just y of s. Additionally, I know that the transform of g is just g of t. So don't worry that you don't know what g is. You can leave its well, you can leave the transform symbolically, because you know at some point you're gonna have to take inverse Laplace transform. And if you have to take an inverse Laplace at some point, that means, and you know, you can see like all the answer choices have a convolution. You know, at some point it's going to be g of s. You know, at some point it's going to be g of s multiplied by some other function of s that you know, but the difference is that you would know like what the other, well, even if you didn't know what the other function is, you know that it's going to be a product of two transforms. So the capital G is going to go back to a small g, and all answer choices have a small g. So am I making sense here? This is important.
I get it.
Yeah, that makes
Okay.
sense.
Yeah, I'm pretty sure I
Okay.
get it. We'll see as the problem goes along, but I think I
Okay. So we have y of s multiplied by s squared plus 4 minus s a minus b. Okay. Minus s a minus b.
Yeah, sure. Your screen. Disable. You gotta enable it first. Thank you. I don't know. Okay, like it should go down. Yeah. So this is what I have for. Like it's not. I want to like to.
By the way, someone is unmuted.
Yeah, make sure to show your working so we don't get. Yeah, that next.
Hey, Alex, I think you're unmuted, by the way.
Something whacked up to this one letter.
That's not me. I muted my mic.
Oh, okay. Okay. Maybe Sashwat?
Yeah, it is Shashwat. Shashwat, can you hear me? I think you are unmuted. Okay, I muted him. Okay. Sorry for that. Let's continue. So we had, I'm just copying the previous line into here. We had y of s is g, capital G of s plus sa plus b over s squared plus 4. It's okay, don't worry about it. Shashwan. So we have to take inverse Laplace of both sides. So it's gonna be y of t and by the way, for those who are following along with the problem, you get the same capital Y of S before I proceed, because
I did.
Did as well.
Okay.
Yeah.
okay, then I can know I didn't make a mistake. All right, so we come here, and that may seem like it's a tough part, but well, A and B are, is it given that A and B are constants? Can I, okay, well, I'm just gonna assume A and B are like constants. They don't change with time, okay? Or like, because, yeah, I'm just gonna assume they're constant. Like, they didn't say anything, so they look to me like they are constants. So I'm just gonna say they're constants. So that's gonna be the inverse Laplace, and same thing as I used last time. We're gonna break down the fraction. Okay, we're getting somewhere. Oh wait, I can't believe they would do this on an exam. I would never do this. G of s over s squared plus 4 plus, it's too many symbols, I guess. I'm not really sure. Okay, so we've gotten somewhere at least. Problem. Well, can you all see the paper I have with like all the 3 inverse transforms we need to compute?
Yeah.
Yeah.
Okay, so b over s squared plus 4, that one's not a, it's not a, like, I mean, that's not, here, let's do it. It's a simple one, so yeah, we're gonna start with this one. That's the, does anyone have a table? I'm just gonna look at the table. It's s squared plus, yeah, so s squared plus a squared, so it's gonna be, so a would be like 2, so it would be b over 2 sine 2t, because when I transform that, it's gonna be yeah, everyone gets this, I hope, right? Self-explanatory, or does someone not get this?
It makes sense.
Okay, next. Same thing, but this time it's a cosine. Wait a second, something's off. It's not, I do this wrong. If I transform cosine 2t, I have, yeah, there's no divided by 2, so this one's just a cosine. I guess. Okay, are we good up to the last line here before I move on?
Yep.
Okay. All right. So now we just have to apply the convolution formula. Yeah. Right. Okay. Well, now we got all three pieces finally. So I'm just
This may be a dumb question, but how did you know to switch G and F when you're calculating? Like, how did you know that it was G of S and F of S instead of F of S, G of S? If that makes sense.
well, you're basically asking how do I know that I can switch the order around so that I can like, because T minus R is messy, so I can like give it to the G, which I don't know, and then I can plug the easier one into the F. Well, the reason why I can just switch them like that. Well, assuming, I hope I'm not messing up, but well, the reason is it's like multiplication. So if I have a multiplication, I can switch the order around, right?
Yeah, so you can just do that for other one.
Yeah, because like it shouldn't matter which one's F and like, well, not to say, well, it shouldn't matter with like which one I
Okay,
do.
I think I understand. Yeah.
Yeah, I would here. Do you want me to like write it down or do you get it? I can
No, I
can
get
write
it.
it.
G and F
Yeah,
are arbitrary
yeah.
and you can set them. Yeah.
Yes, that's one way to think about it. But algebraically, even if you keep them the same, you can you would do, you know how sometimes you change the bounds on the integral, like you would do something like u equals t minus r or something. Then
Yeah,
you can so as an exercise later, I don't think any of us have had time for exercise, but if a professor would say as an exercise, prove that they're the same. And the way you would do that is by making a change of variables in the bounds. So, okay, which I could do, but in the interest of time, let's keep going with the question, right? So just trying to get all the different transforms. Okay. So we have b over 2 sine 2t plus a cosine 2t plus 0t d of t minus r e. Is that not a answer? Let me just open. I think that
It's
That should be
switched.
answer choice number 1.
is that
It's
okay.
it's just switched. The t minus r and t are switched into yours.
Uh-huh,
I
You
okay,
gotta
well,
just pull, you have to just
so-
pull out the 1/2.
yeah, okay. So yeah, it's a product, it's the same thing. Yeah. But so here's the thing. The reason why I did the switch, even though like it's not, is because suppose you actually had to evaluate the integral. It's better. Well, it's better to do the switch in a way that makes it easier to compute the integral, if you know what I'm saying.
Yeah.
Okay,
Yeah, for sure.
next. So do we have any questions about this?
Nope, I think we're good to move on.
We're good, we're good. Oh, so it's already question 12, but we jumped onto PDE stuff like Fourier expansion. So question 13. So question 13. I'm just gonna graph the question, like the graph, because then it's the same thing. So absolute value of x from minus pi to 0, and then it's just 0. Does the graph look correct?
Yeah.
Okay. So this is the graph, then well, they want the okay. Well, they want the coefficient of cosine 7x. So well, I guess
So does that mean we use the an and not bn?
yeah, basically. But yeah, we can do that. So for so what is this function f of x? Okay, so basic Fourier expansion in general is a0 over 2 plus summation of a n cosine n pi x over L plus okay. Is that the I've not done this in a while, so I just want to remember. And then oh sorry, I forgot to write an equals integral from minus L to L of the function f of x multiplied by cosine n pi x over L. Bn is equal to 1 over L minus L to L f of x times sine pi x over L. Just trying to look at my notes to remember if what I did right here is correct. This is correct, right? Like no objections with the formula.
Nope.
It
Okay.
seems right.
Okay, so as someone pointed out earlier, well, the question is asking for A7, right? So what I'm gonna do is I'm just gonna compute AN and then plug in 7. For this specific question, you could actually do like A7 directly, but I don't recommend doing that always. It may not always work. So we're just going to compute an. So an is going to be 1 over L minus L to L f of x cosine m pi x over L dx. So this is going to be 1 over pi integral minus pi to pi. F of x, well,
So I think you would break it up, right? So you would have negative
right.
x
Yeah,
and then 0.
exactly. So the idea here is that if you look at the graph, we have 0 here. So whatever the integral is of 0 times something is just going to be 0. So that is going to be 1 over pi integral minus pi to 0. Well, f of x, well, from minus pi to 0, f of x looks like just minus x, right?
Yeah.
So then that's going to be minus x. So that's going to be minus x multiplied by cosine m pi x over pi. So pi's cancel out. And we're left with the integral from 1 over pi minus pi 0 minus x cosine and x dx. So this is integration by parts.
Also, this is just from me, but I would recommend using the tabular method. I think it's easy and
There you go.
organized.
You
It
took it out
makes
of my
yeah.
Yeah, you took it out of my math. Using the tabular method is probably the best way for, especially when dealing with trigonometric and exponential functions. So I don't know if it's correct to show like the tabular method here rather than just do it normally, because like others may not be familiar with it.
I think you should show it, just so
Show
that
it,
like
okay.
you know you can get a little grasp. Like if you don't know it, like you might be able to pick it up. It's pretty easy to learn.
Exactly. Okay. Fair enough then. I'm going to compute the integral of this. I'm just showing a method for repeated integration by parts. So we know integral u dv is equal to integral uv minus integral v du. So that's going to be, so u is going to be your x squared, and dv is going to be e to the x dx. Therefore, we start with our u. It's going to be your x squared, your dv equal to e to the x dx. I'm going to have e to the x here. I'm also going to have e to the x here, e to the x here. Well, bad example, but as I go down, I integrate. That's the idea. As I go down, I differentiate. That's going to be 2x. That's going to be 2. That's going to be 0. So first one has a positive sign. Second term has a negative sign. So first one's positive, second one's negative. Well, if I keep repeating this, then it should be clear that third one's going to be positive, fourth one is negative, and so on. What's after 0 doesn't really matter. So therefore, integral x squared e to the x dx is going to be x squared e to the x minus 2x e to the x plus 2 e to the x, which is the same thing as e to the x squared minus 2x plus 2. So doing that here, so I've only done that like as an example. So if I need to do x cosine nx because I want to find the integral of x cosine nx, then as I go down this way, I differentiate. So it's going to be 1, 0. As I go down this way, I integrate. So, okay. Well, the integral of cosine is sine nx over n. And the integral of sine is going to be a negative, so it's a negative cosine nx over n squared. So therefore, our answer is going to be integral x cosine nx is going to be x sine nx over n plus cosine nx over n squared.
Isn't it negative? Oh, never mind, never mind. You took the negative out.
Yeah, I took the negative out. It's going to be zero is going to be minus 1 over n squared. No, wait. Minus 1 over n squared. Minus 1 over pi. Put the 0, get 1 over n squared. Take away, what happens if you put minus pi? Well, it's going to be minus cosine, or plus, well, I mean plus cosine n pi over n squared. I feel like I did something wrong. Give me a second. Did I do a mistake? Minus 1 over pi. Plugging in, okay, plugging in 0. Okay, first you plug in 0. So this goes out, you get 1 over n squared. And then it's going to be take away.
I think it should be cosine negative n pi, but other than that, I have the same thing.
Cosine negative n pi.
Isn't it negative? Aren't you putting in negative pi for x? Yeah, but shouldn't, yeah. Well, that doesn't really matter. Like it inside the x, like inside the cosine, it doesn't really matter, right? Just cosine x equals cosine minus x, right? I mean, it wouldn't it just flip the sign if it was like negative pi versus
No, it
pi?
doesn't flip. No, cosine of 5 is the same as cosine of minus 5, right? Okay, well, I'm gonna just carry on, but like I'll see where the mistake is when I carry on. I definitely made a mistake. So pi n squared plus where second. I ran out of paper actually. So I did bring backup because I figured this would happen since we're using half the page. Okay. So we had -1 over pi, 1 over n squared. I'm just gonna bet that this is where I made a mistake. So 1 minus cosine of pi n squared. So plugging in n equals 7 is going to give us -1 over pi. Hold on a second. What is does anyone know what the correct answer is? Good.
Should be -2 over 49 pi.
Give me a second. There.
So what you have right now is correct.
-2. Okay, yeah. So the mistake I made earlier was this is not a plus. This is a minus. I don't know why I was doubting myself. It's simple. Okay, so here's what we had. We had this. There's my paper up. We had this. So just to explain what happened here. This is -1 over pi. X sine x. Wait, x sine nx over n plus cosine nx over n squared. So what happens when we plug in 0 for the first term? If we plug in 0, then keeping this outside. If we plug in 0, then you don't have a sign anymore. You don't have like the x sine x because 0 times whatever 0. What you do have, however, is cosine of 0 is 1 over n squared. So now we evaluate it at 0. We have to take away what we evaluate at minus pi. So evaluating at minus pi, well, it's going to be minus pi times sine n pi. But sine of an integral multiple of pi is always going to be 0. So therefore, that term would go to 0. Now we get cosine minus pi x. Wait, no, minus pi n. But cosine minus pi n is the same as cosine pi n. So I could write this cosine pi n over n squared, and that will give us the right answer. Okay, we all good?
Yep, that makes sense.
Okay.
Where did you get the -1 over pi from again?
That was like here, so. Okay. I hope you can see the whole paper. I'm trying my best.
Yeah, I'm trying to look at it too. And did you change the bounds because of like odd even functions? Is that what you did?
I didn't change the bounds.
Because you went from negative pi to pi to negative pi to 0.
Oh, okay. That we were okay. It's because
I kind of missed that part. So
okay.
Yeah.
Basically, the function is between 0 and pi. The function is 0. Can you see?
Yeah. Okay.
So
So basically, any integral is 0.
Exactly. There you go.
Okay, got you.
Any other questions?
And you pull out the negative because you just change it into a positive x, right?
Yeah, I pulled out the negative, performed integration by parts with the positive x, and kept going.
Wait, sorry, can you repeat the thing that you've repeated twice about why it's just negative pi to 0? I'm so confused there.
Okay.
Like,
So you're referring to where my pen is this row, right?
Yeah, yeah.
Okay. So if I compute the integral of some kind of cosine multiplied by this, that's going to be the integral. Okay, well, so what I want to do is I want to integrate cosine nx from negative pi to pi. Are we good with that?
Yeah.
Okay, so if I want to integrate cosine nx from negative pi to pi, then my left-hand side is going to be this function times cosine nx. So what I can do is I can break the integral. So if I have an integral f of x from minus pi to pi.
You can break it in two, and on the other side it's going to be positive x.
Right, and so so the left-hand side is going to be minus pi to 0 is going to be minus x cosine nx, but the right-hand side is going to be from 0 to pi. This function is just 0, so 0 multiplied by cosine nx.
You basically create into a piecewise type function.
Wait, why is x 0 on that side? Isn't it an absolute value of x?
Yeah, but that's just a graph. Like if you actually graph absolute, it looks like a V, right?
Oh, yeah. Okay. Oh, I see. Okay, I'm stupid. I just didn't read enough of the problem. Okay.
Okay. Sorry. No one. Don't worry. No one's stupid. There's no. It's fine. There's like it's a question with more than 15 steps. You're bound to like miss something. It's fine. It's totally fine. Okay. Next question. Next question is a conceptual one. So I'm gonna. Can you guys see the question on the Zoom?
Yeah.
So not much math can be done here, unfortunately. You could do a little bit. Well, okay, here. So let's look at the choices. Can you all see why is it not? Okay. The function that is graphed is g of t, okay? So if g of t, what is g of 0? G of 0 is just 0, right? From the graph, you can see that g of 0 is 0, right?
Yeah.
So it can't be c or d.
Exactly.
What's left is to, I will explain the logic behind the function, but I just want to show you the quick way to get this. So what's left is to evaluate g prime. So g prime and
Also,
0.
E is still an option. It's just on the bottom.
Yeah.
Okay.
The top.
So now let's look at g prime of 0. G prime of 0 has to be 1, right?
Yeah.
So it's not B, C, or D. It's either A or E.
Yeah.
Just looking at the initial conditions, we were able to get it down to 2 choices.
Correct.
What's the difference between A and E? Well, E is saying that the derivative is going to be 2 multiplied by the summation of an alternating delta function.
Correct.
So it's saying that the derivative, well, let's see what happens when, like when we're at the point t equals a. When we're at the point t equals a, if we evaluate g prime of a, that's going to be 2 multiplied by the summation of -1 n multiplied by the delta function at an of at a. So the delta function at a. Well, if we evaluate the delta function an at a, is going to give us a value of
1.
Yeah, exactly. If you evaluate the delta function at a, is going to give you 1. However, it seems that the derivative is, well, it seems that the slope is changing. So the slope is initially 1, then it becomes -1. So that's a change of so that's like a change of 2 units. It's not 1 unit. If it was E, it would be a change of 1 unit, not a change of 2. So you would need a change, or wait a second. There is a 2 in front of the summation.
Yeah. But since the slope is changing, right? So isn't it's a change in slope that has to be 2, right? Not the slope itself that has to be 2.
Yeah, it's the change in the change of the slope that's 2.
Yes, which is G double prime, not G prime.
Right.
Because if you
Because
essentially what is happening is that the slope keeps changing from 1 to -1, and what they're trying to make sure you know is that that change in slope is 2 at those points A, 2A, 3A, 4A, 5A. So G
Right.
double prime has to be 2, not G prime, because G prime can't be 2. G prime is like 0 at that location.
Yeah.
Or it's not even defined almost. If you take like the basic like calculus integral from like 2 ends, it's like you can't really define it that well because it's almost a discontinuous.
So
Right.
should G double prime just always be 0, or am I misthinking something?
Well, it's mostly 0. Most of the time it's 0, but at the multiples of A, as has been said and brilliantly explained, it's what's your name? I forgot.
Alex? Oh, not mine. Sorry.
I cannot see from here, but sorry. Who? Yeah. Yeah. Who was explaining?
Oh, I was
Because-
saying, yeah, I was saying it.
Okay, Shashwat. Okay, so yeah, Shashwat. This basically, yeah, the explanation that Shashwat was saying it. So, what you check is the change in slope, and not the slope itself. That should be 2. So
Okay, so it goes from 1 to -1.
right, so the slope changed by 2.
Okay. Okay, I
Right.
think that makes sense.
And consider this: it changes by 2, but not only that, you can also verify the sign, because at point A, it changes exactly by -2, right? So
Yeah.
the alternating term, that doesn't help with the question, but for your conceptual understanding, you can see that the alternating term should be n and not n plus 1, right?
Mm-hmm.
Okay. So are we all good with this question? It's a bit tricky, to be honest, but
Yeah, I think the notation is what like makes it extremely like hard to look at.
yeah. Okay. So question 15, are we all good?
Yeah, I'm good.
Yeah, I think so.
Question 15. Well, I'll give you a second to look at the question, but how do you think you should do this question?
It says odd periodic extension. So
Right.
use B at Fourier of B and N.
Any other suggestions? Well, here's the thing with this question. I thought the exact same thing when I first saw it, but actually you don't really need like anything we learned in almost anything we learned in this class. So here's the thing: if I graph this function, why is it tilted? Okay, if I graph this function, 3x minus 7, so slope of 3 minus 7. It looks something like this, right?
Yeah.
So they want you to find the odd periodic extension. So you could, I mean, it's basically the same thing as, so they're doing it between 0 and, okay, so they're, okay, my bad. They're doing it between 0 and 3.
Yeah.
So it's this piece of the line. So if I draw bigger graph between,
Oh, so do we
What
just
is
have to find it at 1 since that's the only odd one?
well, they want you to find it at -5, and the period is 6. So basically,
period
yeah,
is-
it's basically,
Wait, I thought the period is 3.
no, the period is 6. See, that's the thing.
Did he post the solution to this question or no?
I don't
No,
believe
you did
so.
not.
Well, the answer is -4. I can tell you that, and I've done it before. Well, is the period 3? Wait, is the period 3 or
Well, if we go by the same logic, if it was a even function, then I think we could use the 2 over 3.
Yeah, or is it 3 2/3? That's another question. Or
Wait.
3 plus, whatever.
The period is 6. The period is 6. Like the period of the odd periodic extension of d of x is 6.
This may be a dumb question, but why is it 6 if it's from 0 to 3?
There's no dumb questions again, but or why is it 6? Why is it 6? Well, because I guess the simplest way would just be to show you this. Suppose I had this function you're very familiar with between 0 and pi. That function, that's like part of sine, right?
Yeah.
So let me do the odd periodic extension. So what's the period of this? 2 pi.
Oh, of the entire thing. Okay, I get
Yes.
what you mean.
So the period of the odd period, f of x is not g of x. F of x is the odd periodic extension. So it would be like, you know, kind of drawing a half-assed sketch, but like you guys got the point, right?
Yeah.
So for something like this, if I want to find, so if all of this is f of x, then see, this is g of x, that's the difference. This is f of x. So if all of this is f of x, but I know if x is 6 periodic. So if f of x is 6 periodic, then that means f of x plus 6 equals f of x, right? So f of minus 5 plus 6 is f of 1 is going to be, well, I kind of botched it, but yeah, okay. So plugging in, well, f of 1 is just going to be, is within 0. Okay, 1 is between 0 and 3. Between 0 and 3, f of x equals g of x. Therefore, it's g of 1. G of 1 is going to be 3, 1 minus 7, which is equal to minus 4.
So why is the line in the negative quadrants like not at the same level as the other one? Why is it above?
Why is it not at the same level? I hope you're not referring to like how badly the graph is drawn, or are you, because like I didn't draw it like accurately.
So is it going to go from 0? So it's going to go from 0 to 3 and then -3 to 0. And
right, so this portion is kind of like -3 to 0, yeah.
Oh, okay. So
Because,
it's just okay. Never mind.
because an odd extension is asking what happens if I have an imaginary line y equals x. What happens if I take this and I flip it, like, what is the word, like rotate about y equals x?
Reflect.
Reflect about y equals x. So here, if I have this, I reflect this about y equals x, then it's going to look like this. So it's a bit hard to see, but
yeah, the way I think about it is first you flip it across the y-axis and then you flip it across the x-axis, and then you kind of get that.
You flip it.
Is that what you do that for every single periodic function?
Odd.
Well, I
every
mean,
odd function. Okay.
It's for the odd extensions, basically.
Yeah, they said let f of x be the odd periodic extension.
And then for even, you just flip it over the y-axis.
Yeah.
Okay.
Because for even functions, f of t is the same for f of t and f of negative t are the same. So think of like your absolute value functions where it's like creating a v. That's an even function.
Or a cosine, for example.
Yeah.
Oh, okay.
Okay, are we good to move?
So my question is, how do you know that f of x is equal to f of x plus 6? Is that because for all odd functions, since
No, that's because
periodic?
Sorry to interrupt you.
No,
but
go
that's
ahead.
That's because f of x is 6 periodic. So you know sine of x is 2 periodic, for example, 2 pi periodic. Therefore, sine of x is equal to sine of x plus 2 pi, right?
Correct. Can you move it down
Usually-
a little bit, actually? Yeah, thank you.
I don't know why. I think I hit the camera and now it's like at an angle, so we're stuck. Frick. Okay, anyways.
That makes sense though. Thank you.
No problem. Okay, question 16 and question 16.
Jeez.
You've been here for how long?
About
Like 3.5
2
hours,
Yeah.
almost.
Like 4. What are you talking about? We got here 2.
We've been here. We started at like 2:05, so just 4 hours. Yeah,
Almost.
goddamn. Pretty.
It's
Yeah.
5:45, so.
Okay. Do you all want to like take a small break since this is not healthy? I mean, I've been walking around, but like I'm sure half of like I'm in an open
Yeah, I
classroom.
think we should take a
Walk-
break. You guys want to resume in maybe like half hour or something?
Yeah.
Okay.
If you guys are all right to, yeah, if we want to reconvene at like 6:15 or something, I think that'd be fine.
Should we just
Sure.
keep the Zoom on?
Yeah, yeah.
Probably, yeah.
Okay.
Just leave it on. Just mute yourselves and whatever.
I won't
Okay.
be able to come later, but if someone could post the recording after, that would be amazing.
Yeah, we have 2 people recording, so me
That's me a
and
pain in the ass to like share. It's gonna be like so long.
I'll just post it to YouTube and just
Yeah.
like
Oh,
post the
I
YouTube.
do not know how to do that. I'll try.
We'll figure it out.
If you upload
Yeah.
it, upload it to OneDrive, you can share that like file with everybody.
Okay.
That might be easy too.
I'll figure it out.
Yeah, we'll figure it out.
Okay.
All right. Thank you so much,
See
man.
you in 30 minutes.
So are we keeping should I keep my device open since I'm host?
If you could, that'd be awesome.
Oh yeah, I could. Okay.
Oh, should we pause our recordings?
I'm gonna,
Yeah, pause the recording.
yeah, I'm gonna pause it. Resumed.
Okay. Who wants to be the reviewer now? Just kidding.
I can't.
Okay.
This is the part that we've all been waiting for, Jad.
All right. Well, my name's Albara, by the way, not Jad. That's my group name.
Oh, okay.
Yeah. Anyways.
I think
Okay.
we're on 16.
Yeah, I think we're on 16. That's what I'm on at least.
Okay. Question 16. Let x be the 2 periodic solution to the equation 2x prime prime plus 30. Oh, okay. 2x prime prime plus 32 x is equal to capital F of t, and f of t is equal to minus 10 between minus 1 and between minus 1 and 0 is minus 10, plus 10 between 0 and 1. Oh my, wait, God, okay, I don't like this.
I think there might be a solution to this one.
Okay. Oh wait, they do give you the, never mind. I thought I had to do like the hint on my own, which I wouldn't want to do that. Okay. So since we're given the hint, it's actually a much simpler problem. What they're asking is to I see how that is. Okay. So the way this works is your solution, okay, x of t is the steady periodic solution to the equation given. So And the equation and the steady periodic solution is basically asking how does what is the response due to f of t, basically. That's what it's saying. So if f of t is two periodic odd, then we can say that like the steady solution is also going to be an odd function. Yeah, sorry, what were you saying?
Oh, what does it mean by two periodic?
So f of x plus 2 equals f of x. So every 2 it repeats.
F of x plus 2 is equal to f of x? Okay.
Yeah. Or like f of x is f of x plus 2n, where n is an integer, is equal to f of x.
So does that mean the period is 4?
2.
Okay.
The period is 2, not 4, no. Okay. So anyways, back to this. So the way we solve this is, well, if f of t is odd, then I'm going to assume the response, and I'm going to call the response, which is the steady periodic solution. So the book calls it XSP. The response is also going to be odd because f of t is odd. For an odd function, we can represent an odd function by a Fourier sine series. So that's going to be 2 over L, 0 to L. Okay.
Isn't it
Okay.
odd?
One second. Yeah. Okay. So XSP is going to be well, if it's odd, then you can express it in terms of signs. So sine n pi t. Yeah, sine n pi t over. Wait, no, not. Wait a second. Yeah, this looks correct to me. Okay, so Bn is going to be the Fourier sine coefficient, so that's going to be 2 over L integral 0 to L. Trying to Yeah, okay. So I guess you don't even need Bn because so here, I'm gonna just use a new page. So steady periodic is going to be okay. Now I'm gonna plug that back in to this. So if I have to differentiate this twice, this is going to be n squared pi squared over L squared sigma, okay, negative sigma sine or Bn n pi t over L. So then I have 2 sigma Bn plus 32 all of that is supposed to be equal to f of t, and f of t is equal to 40 over pi 1 over 2n minus 1 sine 2n minus 1 pi t. Okay. So I think just having a problem with this. I feel like this shouldn't be here. Or maybe I'll evaluate what these are. So I know L.
Do you have to find
Yes.
B of n?
Go on. Sorry. What?
Do you ever, like, I think before you were writing out what B of n is supposed to be, do you have to find B of n or no?
You mean lowercase b of n? This one?
Yeah, the first term in the series computation.
No. You find it. You find it by comparing the summation of f of t and what happens when you plug in the xsp into x of t into like the diffq.
Okay.
But I'm just trying to figure out where I'm going wrong, because
Can you just say that b of n is equal to 40 over pi times 1 over 2n minus 1? Or no?
no. It's not, no, b of n is definitely not equal to just that, because, well, at least there's like a 2 multiplied here and there's a 32 multiplied here, so.
Okay, what about, well, it seems like it's all odd. That
Mhm.
seems like it's only odd, so what if you make your ends odd as well?
Yeah, I mean, that doesn't affect, and the problem we're getting here is that the ends are, no, is that I'm getting the end term inside the bracket. So I'm sorry for this, but you have to give me a minute to look over my notes. Just give me a quick second and I'll be back. Just give me a minute. I literally just did this yesterday, so what a mind fart, but no problem. It'll be fine. Okay, I figured. Okay. I here. So I'll start over. Sorry. Here. That was can't believe I made this mistake. Okay. 32x equals f of t. Now, as we said before, and with the same reasoning, xsp is going to be a sine. So it's just going to be sine m pi t over f. Okay. Then I have to differentiate this twice, and I can get negative n squared pi squared over L squared Bn sine m pi t over L. Now what I can do here, if that was the mistake I made, is that actually we already know what L is. L in this case is just 1 because L is the half of the period and the period is 2. It literally says let x of t be the 2 periodic solution. So if it's 2 periodic, L is just 1. Now that I know that L is just 1, I can write this as n equals 1 to infinity Bn sine m pi t. And on this side, it's going to be n equals 1 to infinity minus n squared pi squared Bn sine, same thing inside the sign, and just m pi t without the L because L is 1. Now, if I plug that back into the diff eq, then we got 2 Bn sine m pi t is going to be added to 32.
What about the negative n squared pi squared?
Yeah, so it's 32 multiplied by negative n squared pi squared.
Shouldn't it be flipped?
Why are you multiplying the 2 by the x of t and the 32 by the x double prime of t? Shouldn't it be the other way?
Yeah. My bad. Right. So sine m pi t plus 32 Bn sine m pi t. Okay, yeah. There we go. That looks good.
Where does the L go?
The L is just 1. That's why I was confused earlier, because it shouldn't be there. And the reason why is because it's just 1.
Oh, because it's 2 periods.
Because it's 2 periodic, yes. So you got this is equal to 40 over pi, because that's f of t. So 40 over pi n equals 1 to infinity. Well, I guess whoever suggested to use an odd notation, we can do that. It will simplify things. So it's just going to be 40 over pi, 1 over n sine n pi t.
When you get a chance, could you move it down a little bit?
Yep.
Thank you.
So therefore, given this, we can solve for b of bn basically, because where you have the 2 multiplied by negative n squared pi squared, but you also have the 32. So it's going to be well, if you factor the, just trying to understand why the n squared is still there. Yeah, okay, if you factor the bn out, it's going to be this is not Yeah, this is wrong. 3 pi 32 minus. Oh, wait a second. Wait, so B3. So we got B3 equals 40 over 3 pi. Is this correct? I think this is the answer.
Yeah, that's correct. You just have to factor out a 2. Like a 2 cancels out of the 32 and 18 and also the 40.
Yeah. Yeah. I guess.
How did you get rid of the n squared?
I plugged in n equals 3.
Oh. Okay. Oh, it should have. So we're saying that this is odd, so should it be n equals 5 instead?
Sorry, say that again.
Should this be n equals 5 instead? Because we're saying this is n odd, so 1, 3, 5.
I think the second term is just 0. So like the third term is still 3.
Oh, okay.
The second term is just 0. So you don't count. We ignore it. And if you look at it as a whole, then it's like, yeah, 1, 3, 5. But in reality, it's.
I have a question. Where do we get 40 over pi n? Isn't it 40 over pi in the hint? Like, where's the n in the denominator from that?
We switched it from a even to a odd function, I believe.
So basically what we're doing here is the 40, it was 40 over pi. And if you can substitute every 2n minus 1 into an n, then you could say that you're cycling through only odd n's, if that makes sense.
So you pull out 1 over 2 n minus 1 is just n, as because it doesn't make any difference.
Well, no, I don't pull it. You cannot. Okay, here's the thing. You cannot pull an n out of the summation. That's why yeah, you can't pull an n out of the summation. But yeah, that's not how. Yeah, you cannot pull. What I did is I changed 2n minus 1 to n. So now it's 1 over n sine n pi t. Okay. But instead of writing summation from 1 to infinity, I said it's 1 to infinity, but only the odd numbers. Does that make sense? Because it's the same meaning. Like, look here, I can write it out for clarity. So this applies to any series in general. If I have some kind of series written from n equals 1 to infinity, let's say the series is like 3 multiplied by 2n minus 1. Well, that's just like 3 times 1 plus 3 times 3 plus 3 times 5.
So you just said n, you just left it as n and wrote specifically n is odd.
Right. So what I did, which is hand wavy math, not really, it's not really appropriate. But I did this, which still equals 3 times 1 plus 3 times 2. It's the same thing. So does that make sense?
Yeah, that makes a lot of sense.
I could do it the other way, but I feel like they want you to do it that way. You could do it the other way as well. It's the same thing. It's just like someone else said, I can't pay attention to the name, sorry. That the second and fourth, all the even terms are 0 for the x of t in this question. So it's the same thing because all the even terms are 0. So any more questions?
And wait, and all the even terms are 0 because
for x of t.
Yeah, is it 0 because it's negative 10 and 10, and that would mean that if it was even, they would kind of cancel each other out? Like f of t is negative 10 less than 0, and then f of t is 10 greater than 0. So on that period, even if that was even, then it would like cancel it. If
there were even signs.
Okay.
Well, we can draw it out. So something like this. If there was a normal sine wave, it would look like this. If we have something with twice the frequency, it's gonna look something like. No, it kind of botched that drawing up, but
Yeah, I get it.
but you do get it, like they do cancel out. Yeah. Any other questions?
Just a quick question to make sure I'm understanding it properly. You were able to get the 40 pi over n by substituting like n is odd. So you did 1 over n, and since that's constant, you can bring it out. Is that correct?
Everything until when you said n is constant.
Okay. So
Because it's after the summation, I cannot like it changes. I cannot just bring it out.
okay. I guess my only question from there is if it's constant, or sorry, if you can't bring it out, then how do you bring it underneath, like into the denominator of the 40 pi n, 40 over pi n?
Say that again, sorry.
So you have 40 over pi summation
Mhm.
in odd infinity 1 over n sine n pi t, correct?
Correct.
So then you say that -2 n squared pi squared plus 32, sorry, bn -2 n squared pi squared plus 32 equals 40 over pi n. I
Mhm.
guess that step is what's tripping me up because you said you can't bring the n out. So I don't know how you got the n to be in that denominator.
Yeah, I
Okay.
also have that question.
Okay, good question. Well, I guess the technical answer to your question is that I just brought it in. So it doesn't here. But yes, you cannot bring it out. Well, good. At least I'm glad that you're thinking like along the correct lines. Yes, I cannot bring the n out. Big no. So here, so we had I'm gonna try to not use as I will only use the odd end trick. I will not do any other hand wavy math, so you can see like exactly how we arrived at that. No L because L is 1. 2 periodic. This is period 2.
L is always half the period, correct?
For Fourier series formulas, yeah. This is not n odd. This is your usual n equals 1 to infinity. It's gonna be Bn negative pi squared n squared. Yeah, Bn negative pi squared n squared.
Sine n pi t.
Yeah. Yeah, this seems correct to me. So when I plug that in, I have, well, the 32 goes with just 32 Bn. The 2 goes with that, so it's going to be 2 pi squared n squared. 2 goes with that. And then watch what I'm going to do here with like what you said with the 40 over pi. So I'm going to put the 40 over pi inside first. And I'm not even going to use the n odd yet so that it becomes clear and there's no confusion, because the way I wrote it, I was like, it's pretty confusing, I will admit. So you look at this and you check that this part of the equation must be the same as this. This part of the equation is the same as this.
Okay,
So
that makes
B-
sense.
Okay, Yeah.
Mhm.
But yeah,
with the added caveat that I would do the n odd trick like here personally. Like then I would change this to be n odd.
Okay, so you didn't bring anything out, but you brought something in. That makes sense.
Yeah,
Thank you.
and
Sorry
then
about
from
that.
there, no problem. It's just no. It's a good question. It shows you're listening to what I'm saying when I say you can't bring the n out, because literally that's something you cannot do.
so you brought so instead of bringing the n out, you kind of brought the 40 over pi inside, and then you just compared the two summations and then took the
Yeah.
two things that are like in front of sine.
Yeah, and then solve for b of n, and then
Yeah.
once I get b of n, I know x of t in terms of b and n. So done. Okay, question 17. Fun question. Well, here's the thing about question 17. If there was no hint, in all honesty, I would not be able to solve it. Right? Here's the thing. Okay. So question 17. Oh, by the way, before I go into like any PDEs, for PDEs, I go by the solutions that the book, so like the book does the separation of variables for two different scenarios. It does it once for 0 endpoints, and it does it once for when the endpoints of a heated rod are insulated. So what I did is, and in general, not only for this exam, for even maybe like for use in a different class, I would, I know both of those solutions, and everything else would be a combination of both of them, if that makes sense. So, well, you'll see when I get into it. But if basically what I'm trying to say is that if you've never done separation of variables for a diffusion equation, you will be confused. That's what I'm gonna say. But I can help clarify where it comes from. The only issue is that it is time consuming. So if we want to keep that portion towards like the back end, like like the question 5 or things that could potentially be time consuming, but for now I'll have to skip it because it's just time consuming. I will use separation of variables for rectangular coordinate Laplace problems. I will not use it for polar coordinate problems because same thing. I just memorized the solution. But yeah, we could go over them at the end. So anyways, going with question 17. What I do with all PDEs in general and what I recommend you all to do is either draw a graph or write down in detail what your boundary and initial conditions are. So for us, we have a question. So question 17. We have a heat equation, UT equals UXX. And now just writing this, the first thing I want you to notice is usually it's written as UT equals K, the thermal diffusivity constant, multiplied by UXX. So in that case, K would be K would be 1 for this question. Okay. Now second, we have X is between 0 and pi. Okay, we got that. So it's like a thin rod that extends from 0 to pi. So the length of the rod is 1 pi. Time only greater than 0. It doesn't want you to go backwards because it wouldn't make sense for how heat would diffuse. And then here we go. Those are your conditions. So U0 t equals U pi of t, U pi t, sorry, equals 0. So let's interpret this for a second. This is saying that the rod at all times, so it doesn't matter what t you put in, as long as your x equals 0, the beginning of the rod, then your temperature at that point is 0. Same thing goes for the other end. So what's happening here says saying we're somehow keeping the temperature of both ends of the rod 0. For example, there's like 2 large blocks of ice at both ends. So yeah. Second thing is u x0 is equal to 4 sine 4x cosine 2x. And we'll look into that in a second, but let's first interpret ux0 is your initial position, is your initial heat distribution. So this is what your initial heat distribution looks like. So as I've said before, the approach I've taken with PDEs in general is to learn the solutions by heart, but it's also important to know how to derive them. But you know, if you want to solve a question quickly, it's easier if you memorize the portion of the solution. So for a heated rod with 2 endpoints at 0, and you will see how greatly this simplifies, I have learned that the solution is going to be in the form of this. Is going to be u x of t is going to be equal to a summation from n equals 1 to infinity of some value b of n multiplied by e raised to minus pi squared n squared over l squared kt multiplied by sine of n pi x over l. And I can check this because if I put, regardless of what t, if I put 0 for x, all of this goes to 0. If I put pi for x, and in this case, I mean L is pi, so it would be n pi, sine of n pi is 0. So it does satisfy the initial condition.
Do we ignore, oh, sorry.
Do we ignore?
The k? Should the k go in the sign or no?
There is no k inside the sign.
Okay, so if you take the derivative of t, you're going to get
You take the derivative with respect to t of this whole thing.
yeah. Oh, with the
Well,
whole thing?
Yeah.
I thought it was just the e.
Well, the e is the only thing that has a t in it.
Yeah.
So then you would treat everything else as a constant. Well, I get is what you're asking. How does this solution satisfy the heat equation?
Kinda, because like I was thinking, so like if I take the derivative of e, then you're going to get negative pi squared n squared over l squared k times the rest of that equation. And then if I take it with respect to x,
Then there won't be a k. It's the same thing without the k. But that's why the equation has a k in front of this.
okay. Oh, okay. I was just looking at, okay. Yep.
Okay.
Yep. Sorry.
Indeed, no, indeed, this is the difference. Good observation. This is, yeah, there is no k on the sign term. As I said, this part comes from separation of variables. You can refer to the book. I can demonstrate it for you, but if I were to do it, I would do it like at the end so that we don't waste time. Anyways, doing this, I know that the solution looks like this. Well, what's left is to check what ux of 0 looks like, because I know ux of 0 is sine 4x cosine 2x. No, 4 sine 4x cosine 2x, sorry. So ux of 0 is going to be when time is 0. Well, when time is 0, it doesn't matter what my exponential is. And when time is 0, my exponential goes to 1. My sign doesn't depend, so it's going to be sine n pi x over L. However, I also know that my ux of 0 is 4 sine 4x cosine 2x. So we go a little bit off here to rewrite. If you look at the hint, it's clear they want you to like use the hint on ux of 0. Is that I hope that's intuitive for everyone. So ux of 0 is going to be 4 sine for x cosine 2x. The identity, using the identity on that is going to be, which is 4 sine a cosine b is equal to 2 sine a plus b plus 2 sine a minus b. So we're gonna have, it's gonna be 2 sine a plus b. This is gonna be 2 sine 6x. Yeah, 2 sine 6x plus wait, 2 sine 6x plus 2 sine 2x, right? So do we all agree this is the ux of 0 based on the formula?
That's what I got, yeah.
Okay. So that is, so back here, ux of 0 is going to be 2 sine 6x plus 2 sine 2x. Now let's pause for a second and think about this. We have a summation from bn multiplied by a bunch of sines. And we know L is pi in this case, by the way. But we have bn multiplied by a bunch of sines. Is going to give me 2 sine 6x plus 2 sine 2x. So we have that for an infinite amount of n's. So if we only get 2 n's, it means that bn is always equal to 0, unless you are specifically talking about b2 and b6. Okay, do we get that? Are we all on board with that?
Yeah,
Hello?
that makes sense.
Okay, so bn equals to 0 for all n except n equals 2 and n equals 6. So what's left is b2. Well, b2 is going to be b2 is the coefficient for sine 2x. That's just going to be 2. b6 is the coefficient for sine 6x, also going to be 2.
Sorry, could you move it down again? Thank you.
No problem. So we got b2, we got b6. All that's left is to rewrite our equation. So I am rewriting this. I am rewriting this. You see this? That's what I'm rewriting, with the knowledge that bn is always 0 except for b2 and b6. So what am I going to get? I'm going to get 2. So let me get camera problems again. Okay. So now we're going to have ux of t is going to be equal to 2e to the minus pi squared over pi squared, because that's what L is. And I'm just substituting this with this line. That's going to cancel out. Pi squared over pi squared. N squared is just going to be 4. K is just 1. So we did this, we did this, we did this. The left is the t. So 2e minus 4t multiplied by sine nx. It's only sine nx because L is pi. So sine nx when n is 2, sine 2x. Doing the same thing for the other part, you're going to get 2. You're going to get e. And instead of minus 4t, you're going to get minus 36t. Because n squared, because n is 6 this time. And instead of sine 2x, it's sine 6x. So just applying this formula with these. And that is your answer. Any questions?
Can you go back to the page from before? Perfect. How do we know it's b of n is equal to 0 for all n except n equals 2 and n equals 6 again?
Well, look at the, do you see the line where it says ux of 0 equal something? You see that line? The left hand side of it is saying we have an infinite summation, but the right hand side of it is saying we only have 2. So we don't have infinite, we only have 2. So it means it's always 0, except for a specific case, which is when you have sine 6x corresponding to n equals 6, and when you have some kind of coefficient multiplied by sine 2x, which is n equals 2.
Okay.
Yeah. So it's like that's the only way for us to satisfy the condition that that the left hand side is like an infinite summation, the right hand side is 2. So that's the only way. Is to say that they're all 0.
B of 2 is 2 and B of 6 is 6 because
no, B of 6 is 2.
And that's because sine of
6x is multiplied by 2.
okay.
Yes.
When you're looking at the terms, usually the inside number of the trig component corresponds to the numerical number of the series. So like if there's a 6 inside, it's the 6th term. If there's a 3 inside, it's the 3rd term. It's usually the easiest way of like.
Only when L is pi.
Yeah.
Okay. Any more questions? Move on. Okay. Question number 18. Looking at this, we can see it's a diffusion question again. So, well, I guess for this kind of question, you need some knowledge, because you do have a diffusion equation, but it's not asking you to solve it. Well, you could solve it and then compute limit t approaches infinity, but you already know that the e term is, as t approaches infinity, the e term goes to 0 because it's e to the negative something multiplied by t. So basically, you want to solve this equation for when there's no longer any change. What I mean by that is, suppose you have a heated rod and one part of it is way hotter than the other. One part of it is 3000 Kelvin. One part of it is negative 3000 Kelvin. One part of it is 6000 Kelvin, I guess. Just like in the question, they have -3 and they have 6. So one end is -3000, one part is 6000. Then as you let it go over time, you will see that the hot part becomes cooler and the cold part becomes hotter. And at the beginning, it's very, very violent, right? But as you let it go on and on, as t approaches infinity, eventually it reaches some kind of equilibrium. Do we all agree on that?
Yes.
Okay. So when it reaches equilibrium, your change in temperature per unit time doesn't matter where on the rod, literally everywhere on the rod. When we get to like, well, see, it's not really equilibrium. It's more like it's steady state, actually. So you know how in thermodynamics you model, well, that only applies for whoever has taken thermodynamics, but you model devices as in steady state. So d of some property x with respect to time is 0. Yes, no one taking thermo here? I thought like there's some MEs in this.
Yeah.
I'm taking it right now, actually.
So yeah, so if you've taken or are taking thermal and you model devices as steady state, you set the derivative with respect to time to be 0. And it's literally the same thing here. So basically, as time approaches infinity, the things distribution doesn't really depend on time anymore. It's basically that. Like, it doesn't depend on time anymore. It's done like it's done its course, basically. Like, so ut equals uxx. Well, hopefully the explanation I just said, that as t approaches infinity, ut approaches 0. I hope you can see that. I mean, I tried my best. I'm not the best at thermodynamics or whatever, but I hope you can see this. I don't know how to explain. The book has an explanation, but you know, I tried. Okay, so now we know uxx equals 0. So what this function is, it's no longer u, it's more like a part of u. When well, it's more like, so I'm going to call that v. I'm going to call that u function. So either uxx approaches 0, but let's say that we have a function v of x that would model what would happen if you were in steady state. So v of x is steady state. Therefore, if v of x is steady state, then if I take the second derivative, which it should equal to 0, because usually that's equal to vt, but if vx is steady state, then that becomes 0. Therefore, what is that? That looks something like this, I hope. Yeah, equal to 0. But wait a second, v doesn't depend on time anymore. So v is only a function of x, so that's not just this. Well, now v is only a function of x, so if I differentiate something twice and I get 0, it means when I differentiated once, there was a constant. And it means before I ever differentiated it, the function was a linear function, cx plus d. Now, if I take that linear function and I apply the boundary conditions, well, it doesn't matter what time t is, v of 0 is always going to be minus 3. V of 3 is always going to be 6. So if we apply the condition number 1, if we apply condition number 1, you get d is equal to minus 3. If you apply condition number 2 into this, so v of x is now, hold on a second. Yeah, v of x is now minus 3, no wait, cx minus 3. And if it would be 3c minus 3, because so v of 3 is going to be 3c minus 3 equals 6. So c is equal to 3. Therefore, v of x is equal to 3x minus 3. So what they want to find is limit as t approaches infinity of u t of 2. I hope my explanations have explained sufficiently that this is the same, this is actually an equal sign, that this is actually by definition v at 2. So if I plug in 2 into this, I get 3. And I hope 3 is the right answer. Let me check.
It is.
Okay, it is, okay. So it was a bit convoluted and kind of definitely requires you to have seen something about steady state before. Nothing, there's no other way to go about it, rather than it really wants you to understand the diffusion equation, what happens as you go to time infinity. Any questions?
Yeah, sorry. So you say your u as u infinity of x is equal to 3x minus 3, right?
U infinity,
or sorry, u of x as it approaches infinity.
U is a function of both t and x.
Yeah.
So you're saying that the limit as t approaches infinity for a function, for u, t of x is indeed, yes, that is indeed equal to v of x.
Okay. I don't know. I'm just kind of confused on like how it's okay. I'll figure it out because I kind of confused on how you got there for the whole process, and I don't want to waste time. I could figure it out later.
Well, I'm gonna say something that I hope it helps. So basically,
Because the equation is x squared minus 3. So
suppose you have a long rod. Yeah, but suppose you have a long rod. Well, you need to define a function that is basically uxx equal to 0. So like the new function is vxx equal to 0. So suppose you have imagine this in your head. See that there's no getting around it. That's what I keep saying. If you want to really understand, you suppose you have a really long rod. Like I'm gonna make it ridiculous. Suppose you have a rod that is connected to I don't know, the ocean here on Earth, and the other end is the sun. So it's really long, okay?
okay.
And suppose like the rod does not melt or anything. Like it's a pretty good metal, okay? It does not melt. It can withstand all of that, and it does not explode due to the sheer temperature difference. Suppose, okay? Obviously, such metal does not exist in the universe, but suppose then, can you just visualize in your head that over time, in the beginning, you have one part that's extremely hot, one part that's extremely cold, and you're just gonna have like a massive temperature flux.
Yeah. Like a big difference in temperature.
Yes, and the difference of temperature is proportional to the rate of change of temperature, right?
Yeah.
So if I have such a big difference, over time, it's like the rate is no longer going to change. It's just going to be a steady. It's just going to be a steady rate of change. You get what I'm saying? Like it's going to be like temperature is going to be going from the sun to like the ocean, but it's going to be going at a steady rate. At the beginning, it's like unsteady, it keeps on changing quickly because the temperature balance is changing. But over time, you get like, okay, that's it. We will get 1 million joules a second, but it still stays 1 million joules a second. It doesn't change.
So you're saying as the length gets closer and closer to infinity, the change in temperature becomes more and more linear?
The change in the temperature distribution becomes linear, but the rate of change, I guess what you're trying to say is that the rate of change per unit length of the rod will indeed become like a constant corresponding to a linear function.
Okay. I guess, does that make sense?
Yeah, I hope I try to exaggerate this as much as possible to make sense.
Yeah, I think I could get it more. If not, I could always go to office hours tomorrow. But he's open from 3 to 4, by the way, I think.
Question 19. Solve the diffusion equation. Oh, this one's well, I want to put this one in the back end as well. However, there is a shortcut, so well, I'll first go with the shortcut, and then maybe we can start with that, and then if it needs to, I'll do the long solution. I hope it doesn't. Okay, so looking at the heat equation, there's a bunch of solutions. Now, the reason why I usually with this kind of question, I would approach it with like, if I know there's 0 endpoints, I know the solution is e to the negative. I showed you that function before, times a sign. And if it's insulated at both endpoints, it will be a similar function, but it's actually e to the negative multiplied by a cosine plus some constant. As you can see here, our boundary conditions, can you see that ux0 of t is equal to not ux pi over 2t is equal to just u. You have a mixed boundary condition. Can you see that the boundary condition is mixed?
Yes.
Okay, that's very important. So the proper way to do this, well, the proper way to do this would be to, well, I guess the best way to do this is to just do separation of variables, you know, the normal method. But in an exam, that's probably the last thing you want to do. So here's how we do this. Starting with the initial condition, so initial distribution of heat, ux of 0 is equal to 1. Which of those functions has ux of 0 equal to 1? So when t is 0, you get 1. Well, looking at the solutions, if you have if you have a cosine 2n minus 1 x multiplied by an exponential, the exponential is going to go 0. So what you're left with is some kind of so I'll just write this on paper because it got too complicated to be said by the math. Yeah. Okay. So you want ux of 0 to be equal 1. Notice that all the solutions in the problem are, did you know no one would tell you do it like this, but this is a shortcut, so I made this up. You would say ux of t, like if we are to compare all the options we have either 4 over pi. I'm gonna write it as 4 over pi, but we can well, actually no, I'm just gonna write it as some constant. You don't know it's 4 over pi, some constant c multiplied by a summation from, it is from n equals 1 to infinity, but for notation's sake, for like space saving, I'll write n odd. So the odd numbers between 1 to infinity, multiplied by some kind of variable z, where z is dependent on n. So what z of n represents here is, for example, look at question C. It's z of n would be what comes before the exponential and cosine. So the negative 1 to the n over 2n minus 1 multiplied by an exponential raised to, it looks like it would be like minus n squared t, cosine nx. Because 2n minus 1x is the same as nx when n is odd. So, whoa,
Sorry, will we divide by L?
I didn't
no?
divide by, I am just copying what's similar between all the solutions.
Oh, okay, sorry.
And yeah, that's literally all I'm doing. So when I plug in ux of 0 equals 1 into this, then the exponential goes out. So I have 1 equals c, z of n is still there, cosine nx is still there. And this is n odd. So if I know that from the hint, if I know that pi over 4 is cosine x minus 1/3 cosine x, no, cosine 3x plus 1/5 cosine 5x minus 1/7 cosine 7x, and you get the point. between negative pi over 2 and pi over 2, which is a safe range because our question is between 0 and pi over 2, then if I multiply both sides of this series, this is the series, multiply both sides by 4 over pi, then I'm going to have 1. Then I'm going to have 1 4 over pi cosine x minus 1/3 multiplied by 4 over pi cosine 3x. And you get the point. So what I'm trying to say here is that to satisfy this, my c needs to be this number because that's what's multiplied by the cosine. And this number is always 4 over pi. I hope you see where we're going with this. And if you look, most solutions do indeed have 4 over pi.
Oh, okay, so basically you want the summation to represent that cosine change thing.
Basically, yes, it's a cheeky way to do it. But as I said before, in an exam, really last thing you want to do is separation of variables. The memorize is like, if your professor allows you to take a cheat sheet in, right? All the solutions in the book that they solve it for you, write them down. You really don't want to it's just, it's not as bad as I'm making it sound, but it really is time consuming. You will see, I will get to a question where I cannot do it except if I have to do separation of variables.
Yeah, I get you.
Yeah, you get, at some point you have to do it, but if you don't, if there's a way to cheat it like this one, and I guess what I'm just trying to show here is that working off your boundary and initial conditions can go a long way. So let's continue. So C we identified. Now all that's left is Zn. So our Zn is going to be, well, our Zn is, so I'm gonna make a chart. So when n is 1, our Zn is 1. Is that true? Yeah. When our n is 2, when our n is 2, well, there's no 2, there's 3 because it's like counting by odd. So when my n is 3, when my n is 3, it became negative 1 over 3. So negative 1/3. Yes, okay. And when it's 5, it became 1 over 5. So I want to have a series that can oscillate like this, like 1. So that's like 1 over 1. The second one's minus 1 over 3rd. The third one's 1/5. After that is minus 1 over 7. And this means Zn it has a negative 1 to the, it would be n plus 1 because when n is 1, you want it to be. And then your bottom is going to be, well, you could write it in 2 ways, but if your bottom is always an odd number, then, if we're writing it more generally, it's going to be 2n minus 1. So now you have your C, you have your Zn. If you plug those in here, you actually already have the answer.
So I'm
Right.
sorry, why do you want the n plus 1? How did you come to that over like say n?
Because when n is 1, you want 1 over 1.
But what about when n is 3, right? So wouldn't it? Actually, no, that makes sense.
No, you are, yeah, when n is, wait, when n is, okay. When n is 3, I guess what I did here is, it's not really correct to write it like this. It would be more correct to, like this.
Oh, between the
This is-
positives and negatives, is that what you're saying?
Yeah. So if we're writing it more
Okay.
generally, then n is 1, is gonna give you 1.
Okay.
when n is 2, the second term is a negative. So that's going to be,
Yeah.
if that's going to be negative 1/3, then that's going to have to be negative. So you're going to have n plus 1. And if the bottom is going to be the second odd number, it's going to be 2n minus 1.
Yeah.
So that actually, well, believe it or not, that actually does solve your question. Yeah, it really does solve your question. So
And just double checking, we wouldn't have been able to solve this without the hint, right? Because I see no way of doing it.
there is
Yeah.
a way of doing it.
There
But,
is without the hint?
more time, yeah, you do separation of variables directly.
Okay, we don't have to go into it.
And the reason it's answer choice A and not answer choice D is because the cosines also are varying, like the argument.
Cosines are only, the
it's only
cosines are
odd.
only odd. Yeah,
That's why it's 2n minus 1 in the cosines argument, not n.
yeah. Yes, exactly. Again, cheeky way of doing it. You want me to do the long way, sure, but we don't have all day.
It just feels like I'm like breaking the question into like multiple parts and then like only solving parts and then kind of piecing them together at the end.
And basically that's exactly what PDEs are. That's literally, that's why the main method is called separation of variables, because you separate it into different parts, you solve each part separately, then you put them back together.
That's good. I think we
Okay.
can move on.
Question number 20. Okay. For question 20, this is I hope you all can recognize it's a wave equation, otherwise you're screwed tomorrow. Okay, really is a wave equation, Usually wave equations are written like this, but in this case, the coefficient is just 1, I guess. Okay, t is 0, so it's saying that a string's length is 1, so from 0 to 1, and it's also saying that time is greater than 0. That's just normal. It doesn't want you to like play it backwards, basically. So y0 t equals 0 equal y1 of t is the boundary condition, and that means that both boundaries are not moving. So imagine that you have a string and you set both ends of the string to not move. So that's going to be, I'm just going to write endpoints fixed. So the endpoints are fixed. Your initial velocity is 0. Can you all see that? That's yt x of 0 equals 0. Finally, your initial position is sine pi is what they gave you, the 1/10 sine pi x minus 1/20 sine 3 pi x. Hope I got that right. Okay. So again here, same concept with an earlier heat equation question we did. Bluntly, memorize the wave solution equations. So for a wave equation, there's two solutions. You have one solution is gonna be bn sine m pi a t, where a is ytt equal a squared yxx. So a is square root of whatever attached to the yxx over L multiplied by sine m pi x over L, and this is when your initial, wait a second, is this when your Initial position is 0. Well, we can check. So just now I forgot whether this is when your initial velocity is 0 or your initial position is 0. So we can check. So there's two solutions. It's either going to be this one or it's going to be this one. So let's say I'm in an exam and I memorized those two and I forgot which one. Well, I look at the question, initial velocity of 0. Which one, when I differentiate with respect to t, and then I put 0 instead of t, is going to turn the whole thing into 0? First one or second one?
If you put 0 in for t, then it turns the first one to all zeros.
Right, but
Which
when
means it
I
has to be-
put 0,
Which means it has to be cosines.
when I put 0 for the thing that I differentiate,
Then
Isn't
it-
the second one with an cosine sine?
it's cosine sine, yeah.
Oh, okay.
Yeah.
okay, okay. In
So
that
is it,
case, the second one, when you differentiate it, turns to zeros, but the first one does not.
okay, so we're taking the second one as the correct solution for this, right? Okay. So if the second one is the correct solution, well, okay, second one is the correct solution. It means when I do, so if this is y x of t equals this, I'm not doing this anymore. Then y x 0 equals an. Well, cosine goes to 1, so it doesn't really make a difference. Sine m pi x over L.
Didn't you just say it was going to be? Oh, never mind.
Okay. So same process we did before. We should have gotten used to this by now. It's easy to see that an equals 0 for all n, except when, come on, except when n equals
1 or 3.
exactly. And a1 is 1 over 10, and a3 is 1 over 20, negative. Okay, therefore, y xt is going to be, first we do the 1. So it's going to be a1, 1/10. Well, L is 1, a is 1. It's going to be cosine pi t. Multiplied by, well, L is 1 and n is 1, sine pi x. Minus 120, same thing. It's going to be cosine 3 pi t. And then that one's going to be sine 3 pi x, I guess. Okay. Yeah. Any questions? Well, I couldn't properly write that, so I gotta write back here just so, I know you guys can't see clearly sometimes. I'm just rewriting, but if you have any questions, ask.
Harkening back to the sine versus cosine sine. I understand why we chose cosine sine, but that's just something that you have to memorize, correct? Or like just recognize the
Yeah.
solution.
You have to memorize, that for the wave equation, there's two of them. There's one for zero initial position, and there's another for zero initial velocity. The cosine is for zero initial velocity, and the sine sign is for zero initial position. So, well, you don't have to memorize. You could always derive that on your own, but then that would take time in your exam. And you can see that we had to do some analysis after we having already memorized these for a situation that like half of these conditions were already stated like in the book and already solved for. So can you see where I'm coming from? With, like
Yes.
saying to
Yeah.
it's weird that someone would be telling you it's better for you to memorize, but this is just one of the situations where like you don't want to be deriving the quadratic formula every single time you solve for a quadratic, right?
Yeah.
So
Okay.
it's
That makes
like
sense.
this. It's like this.
Okay. Thank you.
Any other questions before we move on to the next one?
Unrelated, but is there going to be the Sturm-Liouville stuff on the exam? I've asked multiple people and got different answers.
Because it
Probably.
depends on your professor. So my professor Menezes is going to put Storm-Liouville.
Okay, just want to check next.
Okay. So question number 21. 5 to go.
Where does that, actually I have one question. Where do the L's go when we get that?
L is 1.
And how do we know L is 1?
Well, it's because they're saying the string is between, like X is valid between 0 and 1. So the string only exists between 0 and 1.
And we know the values for N from the hint they gave us or whatever. Or like
There's no hint for number 20.
Well, not a hint, but the question, like the y of x comma 0. That's how we know the N value.
No, it's because they said 0. It's because they said X is valid between 0 and 1.
That's for L. I'm talking about N. N is based upon the second line of the problem, right? Based upon y of x of 0.
Sorry, I didn't catch that. N.
And
Well, to find a n, we compared the yx of 0 equals 0.
yeah, from the problem, right? Okay, and it's basically the coefficient of pi x in the problem statement.
Coefficient of what? Sorry, I'm not.
The
catching it.
coefficient of the pi x that's inside the sine and cosine, the sine terms in the problem, like 1 pi x and 3 pi x. That's how we know it's n equals 1 and n equals 3, right?
Yeah. Exactly. Yep. Exactly. Sorry for that. I was just not getting what you were saying for a bit.
Oh, you're fine.
Okay. 21 Laplace equation. So this one, I memorized the solution, but difference is I'm not gonna say memorize this. I'm actually gonna go like for the actual separation of variables for this one, and you're gonna see why in a second. So 21. So that's gonna be I'm gonna try to work through this quickly, so please like stop me if you don't get what I'm doing as soon as I write it down, as soon as you see it. So that, because it's a bit long, so I have to write quickly and I can't like explain while I'm doing it, I guess. Okay. Okay, so I'm gonna stop here and make a comment that at this point, I have two equations. I have something involving y and its derivatives equal to a constant. I have something involving x and its derivatives equal to a constant. So I can turn this into x and its derivatives equals a constant. So that's just going to be ordinary. No longer is it a PDE. I've broken it down into two ordinary differential equations. Second one is going to be okay. Let's focus on this ODE first. Well, and I know that u is equal to x of x multiplied by y of y. But I also know that, wait, can you guys even see that? I can't see if you guys can see that. Yeah, you guys can't see. I was writing somewhere and you guys couldn't see. So I'm going to rewrite that. So I know u is equal to x of x multiplied by y of y. So, and I know that y of 0, x of x is ux of 0, which is equal to y of b. Yeah, y of b. Yeah, y of b x of x equal to 0. Well, x of x can't be 0, right? Even though that satisfies the Laplace equation, not useful. It would mean like u is 0. Doesn't really help us. So therefore, I have to make y of 0 equal to 0. I have to make y of b also equal to 0. And using the same logic, here it's a kind of a skipped step, but it's really simple. X of a is also 0 using the same logic. Hopefully this makes sense without having to explain. Well, yeah. Well, we can see that we can see that the y is something that, well, y is like, it starts at 0. I'm just gonna write, I'm just gonna write the OD. There's just no point. Y equals 0. So if I do this, well, I could solve this. If I do solve this and I get some kind of, I'm gonna get like a sine something plus b cosine something. I know there can't be a cosine because y of b is 0 and y of 0 is 0. So it has to be a sine. The y function has to be a sine. So y is going to equal to sine of something. So let's say sine m pi y over L. Well, yn would be that, but y in general would be sine pi y over L. When I plug 0, I get 0. This satisfies the. When I plug b, I also get 0, which means L is b. So that means y is equal to sine of pi b. No, sine of pi y over b. There we go. So we got it. We got rid of our y. Now x of a equals 0. That's a bit of a tricky one. Well, you know the value at a is going to be, you know the value of a is going to be 0. So it's going to be, well, it can't be, okay, here's the thing. If the value at a is 0 and a is the endpoint for the x values, so let me check the initial conditions. Well, you also know u0 of y equals sine pi y over b. So basically what this is saying is that x of 0, y of y is going to be sine pi y over b. So x of 0 is going to have to be 1. So let me consider this for a second. X of 0 is going to be 1. Well, I mean, this is definitely true, and just okay. Well, we're gonna proceed anyways. So I need a function that is when x is 0, the value of the function is 1. And when x is at some value a, you get 0. So this would be a. X of a equal to 0. That's so. So the only option I have here is the only option I have here is hyperbolic sine. You may think cosine, but the reason why that wouldn't work is because a hyperbolic cosine is definitely not hyperbolic cosine, because hyperbolic cosine does not have hyperbolic cosine does not have a 0. Like it never equals 0, but this equals 0 when x equals a, so it can't be hyperbolic cosine. So it's definitely hyperbolic sine. However, it's not any hyperbolic sine. Hyperbolic sine usually looks like this. So we need to somehow change this so that it's somehow decreasing. So how can I accomplish this? If I know x of 0 equals 1 and x of a equals 0, and I know it's some kind of hyperbolic sine. So sine. So it's going to be sine h something. Now, whatever I put in here, like I want to put in here something that when I plug a in, it becomes 0. So that's going to be sine x minus a. But I also want to fit it in a way that, so I still have something here. I didn't say what that is yet. But I also want to fit it in a way that I have sine h here, that I want to make the value of the function 1 when x is 0. That's only going to be, well, if well, the value of this is, when I plug 0 into this, it's going to be something here. So it's going to be something like this. So all that's left is to determine what this constant is exactly, so that I can fit the curve so that it exactly looks like, so that it can hit those 2 points, I guess. I mean, a regular hyperbolic sign looks like this. I guess it would have to be some kind of, some kind of fit to be like this. So we know that the length, we know that, try to think of a way to explain this, but because I'm sure it does not seem intuitive now, unless you've done like a lot of Laplace equations. Trying to explain, but basically what's in here is supposed to be pi over b. But I'm trying to think of the correct explanation for why that may be. And that does solve your problem, but I still need to explain why this is pi over b. So correct answer is obviously this multiplied by the y we found, which is sine pi, what was it, sine pi y over b. So I know this is the correct answer. Just trying to explain why is it pi over b. I mean, essentially it's the same reason for why we always write like n pi x over L to be as general as possible. Yeah, I don't know, I'm a bit stuck here, to be honest.
I think it's because if you keep it as pi over b, then if you take the double derivative, it'll equal the same derivative if you take it as so if you take the double derivative of a sine of pi y over b, you're going to get negative pi squared over b squared. And then if you take the double derivative of sine h pi over bx minus a, you're just going to get pi squared over b, and that will, if you add those together, they'll equal 0.
Yeah, I guess. I guess we could also do, you could also do something like this. So this is like, And then if you plug the initial condition that that x of a equals 0, I guess it's not entirely correct. Trying to figure out what's going on. Oof. Whatever, this is a bit of a messed up question. I guess I have to say I am beat. Like I could solve it in an exam, but if I can't explain it, then I don't understand it well enough, I guess. Do you want to move on to the next question, or I guess some of you would still be unsatisfied with the explanation.
I'm cool with it if everyone else is.
Trying to think of a
I'm good to move on. Some of the concept is still a bit like fuzzy to me, but I can figure it out later.
okay. All right. So question 22. Oh God, this only gets worse. This only gets worse indeed. Literally the same. Okay. I'm gonna admit that I'm gonna run into the same exact problem again. So for now, I'll skip it. For now. I'm gonna go into 23. Is anyone keeping a backlog of all the questions we skipped so that we could come out and like properly do them later?
I think we skipped 5.
We skipped
2.
2 as well.
Yeah, 2. And this one, I think that's it.
Okay, and then 22/21. I'll figure out an explanation for those
Wait.
later.
What about 22? Is it the
Same.
over B part?
What did you say, sorry?
Is it just because you don't know why it's over B?
It's not that I don't know. It's I messed up the separation of variables somewhere in the middle, and I don't know where I messed up, so I don't want to like go back and back step like 10 steps basically.
Okay.
So just give me, let's do all the others, and then like I'll give you like the proper way. Like it's probably somewhere in my notes because I've had the same problem over and over, but okay.
Also, number 23 and 25, I don't think Menezes solves it. Like it's not in his solved solution set. 23
Okay.
and 25.
But
Yeah,
we can.
22 is, but
I mean, I've never solved 24, but just by looking at 23 and 25, I know I can solve them.
Sounds good.
24 is solved.
Yeah, he
Menezes.
does 24, but
Okay.
again, like his solutions always that tend to skip like 5 steps in between each step. So
Yeah.
I don't know how good they're going to be.
Okay, 23. 23. If you give me just a second. For this one, I'll also pull up, I know how to do it, but I'll also pull up my notes so that I don't make a mistake like while I'm solving, because that's not fair to you guys. So okay, 23. Um, Okay, so it's two-dimensional, it's polar coordinates. We're allowed all theta, but r cannot be greater than a. So it's some sort of circular shape, so it's like a disk. I hope that makes sense. Now, if it is a disk, and this is going to be a, I guess, let me look at this. It says UA. Okay, yeah, fair enough. So, okay, so it doesn't tell you much information, but you can start making reasonable assumptions. What I mean by this is, well, what I mean by this is you, well, what I mean is that you can say that you like this is in general, you are minus pi is going to be the same as u r pi, because like one you're sweeping clockwise, the other is sweeping counterclockwise, but you end up at the same place. Right? Does that make sense?
Yeah.
So I don't know why they don't put this in the question. You know, it's like, imagine this was an exam, never done this before. I don't know how you're supposed to know. You're gonna have, you know, it's the only way. So second thing is the same thing, but I'll do it for the rates. But yeah, I will have to admit this does upset me somewhat that, you know, they don't tell you these two equalities, but you know, you do need them to solve this. So separation of variables again.
Could you move the camera up or thing down?
Move the camera up like
Yeah.
this.
Yeah, there we go.
Okay. I thought you guys see better when it's zoomed.
Oh, well, basically just you need to move the paper, I guess, then that also worked.
Okay. Can you see now anyways?
Yeah, it's fine.
Okay. I use those because it's a convention from where I learned them. You don't really have to use G and phi, but it's just a convention. Well, you can see from the boundary conditions that u pi has to be, well, 5 pi, sorry, has to be the same as 5 negative pi, because g of r can never be 0. Well, g of r, well, not can never be 0. G of r is not the 0 function, because that would mean it's a trivial solution, which we definitely don't want. You can also say that the angle derivative equality is the same thing. If you get this, you get this. Okay. Now we're making some progress, I would say. Now, I'm going to keep this on the side, but in polar coordinates, I'm doing it here. In polar coordinates are Laplace equation, and I'm copying this directly from the question. URR plus 1 over R, UR plus 1 over R squared, U theta theta equals 0. So it's going to be, well, your URR is basically going to be, G double prime. Wait, your URR is supposed to be, well, I don't like writing it like this, to be honest. gonna write it like this because especially for this problem, it's the same thing, but though. Not really sure why they would write it like. I could like my solution will be more understandable, I guess. This is u with respect to r. 1 over r squared. Okay. So we use that and we plug that in here. You're gonna have 1 over r partial derivative with respect to r. Well, partial derivative with respect to r of u of what's inside here is also a derivative. So it's gonna be dg dr, I guess. So dg dr multiplied by phi of theta, I guess. And then all of this that's inside is multiplied by r plus 1 over r squared. The second derivative with respect to theta should be fairly obvious. That's just going to be this. There we go. Okay. So notice, taking derivative with respect to r, I can't like pull the r out and cancel this one. It's not gonna work. However, if I'm taking a partial derivative with respect to r and I have a function of theta, I can pull the function of theta out. So if I pull that back here, multiply by 1 over r, and well, at this point, it's just going to be ordinary derivative because what's inside, I pulled the only function of theta. Sorry, I got headphones. Can you hear me now?
Yeah.
Okay. Yeah. So so it's going to be only a function of r. That's going to be r dg dr. It's going to be plus g. I'm going to write g, or maybe for consistency, I'll write g of r. That's going to be 1 over r squared. Okay. Well, now all I have to do is, I know this equals 0, so I can start separating variables. What I'll get is r over g, and I skipped. It's just algebra. It's just rearranging. I skipped some of it. Well, it's gonna be okay. So it's gonna be this. And finally, we get to like actually do some of the things we learned.
Can you go back real quick to that other equation? I didn't get it down.
Yeah, sure. Give you a second.
Okay, I got it.
Continue now. And basically, we get double prime of that plus that is going to give me 0. And this is going to be equal to 0. So I know that this equals this. And then, yeah, I know that this equals this. And if I know that, then what kind of function behaves like this? Cosine, right? So that can be cosine. It can be a cosine. It can be a cosine, and well, literally any cosine. Yeah, any cosine will work for this. Yeah, I guess any cosine will work for this. And I guess I just want to solve that the derivative. Well, I also know that, I also know that this is true. So I guess it can also be a sine. So it could be a cosine, it could be a sine. And I guess the eigenvalue would be like, the eigenvalue would be this, like the lambda here would be n squared because it's the square of the coefficient of theta. That you should get from your ODE class. You should, because if you solve for this, you're gonna get well, if you solve for this, you're gonna get r squared, like the characteristic polynomial is gonna be like this. So you're gonna get like r equals plus minus root lambda I. So then you get like your a cosine plus b sine lambda. So your root lambda is n, that means your, or the other way around, I guess. The same thing, no problem. So the troublesome part here is that what I do next is not covered neither in MA 266 or 262. And I think that's like everyone here has either done 262 or 266. And I don't know if like I learned it in my free time. I don't know if it's required or like I don't know. I don't think anyone here has like done it. I've personally, I know I've been in 262. They have not taught me that it's a way to solve an ODE, but it's not gonna, like, basically, yeah, it's not gonna work. So unfortunately, I guess this is gonna be another case of like the heat equation, and you will have to like memorize the solution for polar coordinates once again. So I'm just gonna skip straight to the solution because, you know, not only will deriving it take a time that is ridiculously long, it also will use a technique we have not been taught that, at least not at Purdue. So we'll have to deal with it, I guess. So the general equation for this kind of Laplace problem is going to be this. Again, if you have an equation sheet, put that on there. Did anyone actually go to the Menezes lectures when he was explaining this and see if he taught a way? Did he have a way in class like teach how to derive this?
I
Or-
don't know. Is that r to the power n, or is that r to the power r in your first summation?
It's r to the power n.
Sorry, I actually have to go right now.
All right.
So I'm probably going to stop the recording. I'll figure out how to upload it.
Yep. Well, I
Um,
mean the exams
tomorrow.
I feel like. Yeah.
I don't know when people would watch it. Probably tomorrow.
Yeah, I feel
Or
like
tonight.
it would be a. I feel like
Or tonight.
I feel like the recording would be a waste of time since. How about this? Don't submit a recording. I'll submit a PDF of the solution.
No, I think the
You can-
recording is good though, because the recording still has like some like explanation for
Discussion.
certain problems. Like
Sure,
like
sure.
like especially from like problems 1 through like 20. I think we went pretty in deep and like we're able to solve them.
Yeah, until we get to
Might be.
until I started mind farting, I guess.
Hey, that's
No,
okay.
not
You were a big help to a lot of us here
Yeah,
today,
Yeah, it's all good.
and we really appreciate it. So yeah, I'll see you guys if I see you. But yeah, thank you so much for this session. I really appreciate it.
All right. Okay.
See you later.
Bye.
Thank you.
With that being said, now that we have, if you start with this, then the question is not even a question; it's a joke. So, UA theta is good. It won't even take like 1 minute. So UA theta is sine 3 theta. So you plug A into this. There's no cosine, so an equals 0. Yeah, there's no cosine, so an equals 0. There's no cosine, n equals 0, and bn is going to be and bn, the same logic we used before. Bn equals 0 for all n except n equals 3, and b3 is just 1. So
And that's the coefficient of the sine, right?
um
For 3.
that's, hold on a second, I think I put it up somewhere. That's the, I guess I went too fast. Ignore anything about b. No, we're not there yet. So sine 3 theta equals summation. Well, it equals just, well, if sine 3 theta is going to equal summation, n equals 1 infinity to bn rn sine n theta. Well, first we know that we only have n equals 3. So if n equals 3, we have r cubed sine 3 theta on the right hand side. But on the left hand side, we only have sine 3 theta. Really? Yeah, we only have sine 3 theta. So oh wait, I put UA of theta. It's supposed to be a cubed, sorry. Right. So I want a coefficient that will give me So I want to have a coefficient, right? So it's a cubed bn. The bn is still here. Well, b3, I guess, capital B3. So then comparing like this side and the fact that there's just a 1 here, b3 is going to be 1 over a cubed. If b3 is 1 over a cubed, then yeah, b3 is 1 over a cubed, and you know an always equals 0, bn always equals 0, except n equals 3. So then you know your solution is going to be b3 r cubed sine 3 theta, and instead of b3 r cubed over a cubed sine 3 theta. But even though memorizing this, yeah, so basically what I want to say is that you just memorize this, because if you don't, I really don't know, like,
Can you move your paper down?
down or like up? Okay.
Yeah, this is it, perfect.
Okay, so basically I just don't know what to say besides, if I'm just being honest, man to man, you gotta memorize this. How, like, if you're gonna try to derive this on your own, it will take you an hour. But to do it without any mistakes, it will take you an hour. So I just don't know what to say. It's not even like, heat equation or like Laplace, but in rectangular. Like, you can get all of them. This one, the polar coordinates,
It's just
I doubt
plug
a
and chug, just
professor.
memorize it.
I doubt a professor could even do it in less than 10 minutes, and they may get it wrong. So it's
Yeah,
not
knowing
appropriate for
Menezes, he would probably get it wrong. He always like goes back on his work during lecture.
So I just don't know. I'm sorry that I'm like unable to show you like how
it's
you
fine.
get
It's
there.
You're good. Honestly,
Yeah.
yeah, it's easier to know, I guess, kind of the truth of it and what we need to know for the exam, that you just have to memorize it.
If you see a polar coordinate question with like, and the only, like, you get this, and literally the only thing they say is r is less than some number, and then they give you initial condition in terms of like sines and cosines. You got to do this, even if it's not in terms of sines and cosines. You got to do this. You can, if it's not in terms of sines and cosines, you can force it to be a sines and cosines using Fourier series, right? That's the whole point.
Yeah.
Okay. Want to move on to 24.
Wait, real quick, so I just want to reiterate, it's supposed to be 1 times sine of 3 theta is equal to a cubed times sine 3 theta times b3. It's not r cubed, it's a cubed.
Because I plugged in UA of theta. It's
Okay.
only sine 3 theta when r is a. I hope that makes sense.
Okay.
Yeah. So yeah. Okay. Question 24. Something a little bit easier, I guess. Expand the function f of x between 0 and L into a series of eigenfunctions for the strongly revealed problem. Y double prime plus lambda y equals 0. Y of 0 equals 0. Hy of L plus y prime of L equals 0. H is greater than 0. Never done this question before, but seems doable. Given the eigenfunctions are yn of x equals sine, is that alpha n? It is alpha n. Sine of alpha n x, where where it says like the next alpha is bigger than the one before it?
What's up? Sorry.
In the
Yeah.
part of the question where it says the next alpha L is bigger than the one before it?
Yeah.
That's just saying that it's Anyone read 10.1?
No. I'll be.
I read it, but it was kind of confusing.
So if
But
you
it's like
read it,
each one gets bigger in a series kind of
right?
thing.
If it's right, so basically all it's saying, all that means is, well, all that means is it's a regular storm Liouville problem, so it's not an irregular or singular. I guess that's what they call it. So storm Liouville problems are either regular or singular, and given the increasing sequence as well with like other things in the conditions, you can tell that this one's a regular one. I mean, in general, 10.1 only covers regular problems anyway, so you don't need to worry about, you know, singular problems. Anyways, let's get started with the solution. And I don't know why this is tilted. I have no clue. Okay, anyways, let's get started with the solution. So the way you want to approach this is say let x, oh wait, you can't see this. Yeah, let x be the series of eigenfunctions. So series of eigenfunctions is a summation Cn from m, some random number m, ym, that's a function of x. The series of, so ymx is the nth eigenfunction, I guess. Okay. So now what we need to do is, if you didn't read 10.1, you know, this is not gonna make sense, you know. I'm trying to find a way to wing it. It just doesn't exist. So what you need to do is integrate both sides with respect to yn r. So both of those are function of x. So yn is the nth eigenfunction, and r of x is the weight function from the storm Liouville problem. I think in this case r of x is 1, but we will look into that into a second, okay? And we want to do it from 0 to L, because those are the bounds given in the question. Next, we have Cn, m equals 1 to infinity, and do the same thing, integrate ym of x, yn of x, r of x. Well, the ym was already there, but well, this integral is always, you see the long integral on the right hand side? That one is always 0 for m is not equal to n. That will always be 0. So basically what happens is you get 0 to L x, y, and x, r of x. And that's going to be, it's always going to be 0. So it's just going to be Cm, except, okay, so if it's always going to be 0, the whole thing is going to be 0, except for when n is equal to n. So as long as n falls between 1 to infinity, it is, then basically when m is equal to n, you're going to get a non-zero value. So that means you're going to have yn of x squared, r of x dx. I guess what's left here is to just say that Cm, because let's look at the question. The question's asking for like the full. Well, the question is asking for, holy shit, look at the answers. Does not make me feel good. Because anyways, the question is asking for, what CM is basically. So CM is going to be the integral at the top divided by the integral at the bottom. Okay. I'm gonna pause here for a moment and ask, are there any questions? I mean, if you didn't read 10.1, I'm sure you have plenty of questions. This can absolutely impossible to make sense if you didn't read 10.1. I'm just gonna have to be honest. But so what's
the denominator of the CM?
It's gonna be the integral from 0 to L yn x squared multiplied by rx.
Okay. Rx.
For
So what
this
I'm gonna-
question, oh, sorry, go ahead.
Yeah, so what I'm gonna say here is, out of the 7 people here right now, excluding me, who has read 10.1 and who hasn't? Because if it's like it's only one person who read it, then it doesn't really make much sense to.
I had read it. I'm not sure who else.
Oh, I haven't read it, so it doesn't really help. Like, I'm just writing it down so like after I watch the lecture, I can refer to something and not be completely lost.
I will highly recommend the book over the lecture, but okay.
The book for 10.1.
Much better.
Yeah, I'm gonna be honest. I never read the book, but I started reading it this week just to see, and it's helped significantly more than like Park, even some of the online lectures.
We're talking about the textbook from
Yeah,
my lab.
the
Yeah.
e-text, like it's surprisingly informative, and it like highlights the equations. I'd recommend it too.
It's very boring and tedious to read, but it helps you get the point.
Might just have to do that.
So yeah, so basically the solution to this problem lies into getting CM. And CM, well, the integral at the bottom, well, so R of X for this problem is actually just 1. Y of n of X is given. So can you see, for those who've read 10.1, that the bottom is given? Like that the bottom, the denominator is actually given.
It's just sine alpha n of x squared, right?
Right, because R of X is 1. So then if I will proceed with this, then okay, so CM equals I'm still going to keep it in its integral form, not yet going to make the substitution. I'm going to make the substitution up here.
Would you say that this is the most important equation to know for the Sturm-Liouville problems?
This is not really an equation. It's more so a result of applying the theorems.
Okay, I got you. Yeah.
Yeah. So like, it basically is a more generalized way of like saying how functions are orthogonal to each other, treating them like they are vectors.
Okay, yeah, that makes sense.
That's why like they cancel out to 0. And yeah. And and knowing R of X is 1 is just from the standard format of the storm. You'll see next question more about like R of X, Q of X, and P of X, I guess. Okay. So then this problem reduces to just solving this. So the integral on top is going to be integrals. I know the integral on bottom, so let's just focus on solving the integral on top. That's going to be just 0 to Lx sine alpha n x. If I am not wrong, isn't this just don't you just treat alpha n as a constant, and it's basically yeah, treat alpha n as a constant, and then you will get the value you want. So basically, if you take also x, this is the tabular method that was mentioned like a few hours ago. So x is 1, then 0. Sine alpha x is cosine, negative cosine alpha n x over alpha n. And then it becomes negative sine alpha n x over alpha n squared. And you do plus minus. I don't even know what I'm doing at this point, but that's going to be minus x cosine alpha n x over alpha n plus sine alpha n x over alpha n squared, the whole thing, 0 to L.
I double checked on Symbolab and that's what it came out as too.
You did all this, you did the integral?
Yeah, that's what it came out as. At least just the part before plugging in the 0 now.
The part before plugging in the 0. Sorry, I'm confused. What?
I'm just saying I got the same thing as you up to there. Like
Up
I
to
got the
this.
same answer. Yes, I got that as well.
Okay. Yeah, yeah. Okay. So plugging in L for x is going to be, well, if you plug 0, it doesn't matter. So just minus L cosine alpha n L over alpha n plus sine alpha n L over alpha n squared. And now what we have to do is divide all of that by the other integral. But dividing by, like the other integral is multiplying by the denominator, which is 4a, divided by 2 alpha L minus sine 2 alpha L. I'm gonna open a new page. And I guess, do we have space to rearrange it on this page? I guess we do. So rearranging it here is going to be sine alpha n L over alpha n squared minus L alpha n minus L alpha n cosine alpha n multiplied by,
Can you move the notebook a little bit down?
sorry, what?
Oh, can you just move the notebook a little bit down? Yeah, there we go.
Like this.
Yeah. That.
Okay. So I just did the top part, and I have to do the bottom part. And I don't.
What are we multiplying that first term by? That what's that outside? Is that 4a?
4a, yeah. Don't know why the camera shifted at an angle. Anyways. Well, I guess it's worth noting that it's for alpha n. I don't know what's wrong with me. What is A even? Bro, I'm getting so sleepy.
A
What-
is
what
the
is-
same as alpha. They in the hints they use A as like a placeholder, but it's
Yeah,
really
yeah.
just alpha. They're the same.
Yeah. Okay. So now all that's left is to rearrange this, basically. And I'm having a hard time doing that, to be honest.
You're good. If you want, the Minez does have the answer.
Yeah, for this one, he does have it
Yeah,
up, and
similar
it's
to
pretty
it.
similar to what we have like right now.
Yeah.
He kind of distributes everything. And then basically he has a 4 alpha over your like last term, and then it's identical.
What kind of rearranging magic does he use after that too?
You don't have to do much from here. Once you cancel the alpha squared in the denominator, take off the squared with the alpha from the 4 alpha, and then
Yeah.
bring in the 2 underneath. I think it comes out to answer letter A.
Yeah, it comes out to A. It's just this like cancellation.
Yeah, all you have to do is cancel one thing, then
Okay.
combine it all.
So at least I was doing something that is correct, I guess.
Yeah, no, it's all good. It makes sense.
Okay. Yeah, I'm sorry. Like, this is even new to me, I guess. So, like the
You're good.
10.1 stuff.
We've also been going for what, almost 6
7
hours,
hours.
6 and change, 7 hours.
I have the timer. It's at 6 hours 45 minutes. So
Uh,
it's
What a
insane.
marathon.
Yeah, honestly. If you
Mad
want,
marathon.
we can like go through. I'm probably gonna go to office hours tomorrow to ask about like problem 5 and some of the other ones. If you want, we can either not go over 25 or we can quickly go over 25 and then call it a night.
We're so close
25
to
is
the end.
25 is easy.
Yeah, exactly. So we can, well, not exactly, but like we can go over that and then.
Yeah.
Okay.
Fine,
We're so
Y'all-
close to the
Y'all
end.
up
might
for
as well.
25?
Oh hell yeah! Might as well just finish it.
Finish strong.
Exactly.
Yeah, let's do it.
Dude, how is this exam gonna be in 2 hours? That's what I'm thinking.
Well, this is why you memorize the hell out of the shortcuts.
Yeah, that's what I'm gonna have to do.
It's the last math class, man. Just,
True.
you know. Okay.
As long as I don't fail the final, that is. If I get a 0 in the final, then I might have to take it again.
God, oh,
At
with a
that point,
different
I would just
professor.
take it somewhere else.
Yeah.
Yeah,
It probably
take it
doesn't
online.
get accepted for like credit.
Yeah.
Okay, so these questions. Okay, so I'm just gonna tell you something. I'm not gonna have time to prove it, so you're just gonna have to believe me. You have no other option. So
With all you've done so far, I will believe you 100%.
okay,
Exactly.
if
dude. You have nothing
if
to
you're-
prove.
okay, thank you for the kind words. If we have linear homogeneous differential equation, you can like this, like something times y prime prime plus 1 minus plus something y plus something y equals 0. You can actually write this in Storm the usual form. Well, I probably didn't need to say that because the question asks you to to write it. So it's probably possible to write it. I'm telling you it is possible to write it. Okay. Okay. Well, the way I'm gonna teach you the general way to do this, might as well. In the exam, probably not gonna give you a simple one. You could probably tell just by looking like this one. But before I start, I just want to say that if you ever get stuck with a question like this, you know how to differentiate. You know how to use product rule. So if you get stuck in something like this, just start plugging in random q of x, and hopefully you get it.
That is true. It might just be easier to just use the answers than actually like try to
Right.
figure this out.
But if it was more complex, you would need to do the method I'm about to show you, which isn't even that long. So, and it's also reminiscent of the first thing we did with 262 or 266, I guess. If you remember the first order linear equations, where you had to like find integrating factor, like multiply both sides, and then do you remember? No one remembers. Okay, it was the same thing. So what we do first thing, divide by x everywhere. So y prime prime plus 1 minus x over x, y plus lambda y over x. Well, yeah. That's the same thing as going to be y prime prime plus 1 minus x plus lambda over x, y equals 0. Okay, good. Now I'm going to multiply by something p of x. So y prime prime multiplied by p of x plus 1 minus x plus lambda over x multiplied by p of x, y is equal to 0. Now, wait a second. What do we do from here? Oh, okay, I know. So y prime prime p of x, and this is really convoluted, but that is equal to y prime p of x, the whole thing prime, take away y prime p prime of x. Does that make sense, that sentence at the bottom?
Yes, yeah.
Okay, good.
And in the second to last line are you multiplying that fraction times p of x? Then
Everything
y?
times p of x, like the whole equation by p of x, both sides.
Okay. And then y prime prime p of x is equal to
This product rule, take away the extra part, I guess.
okay.
Geez, the amount of paper was wasted today. Okay.
I'm sure.
Math is not good for trees, I guess.
Okay. So, well, so now we got to write our equation. Our equation is now going to be y prime p of x prime minus y prime p. Oh, crap. What the hell am I doing? I shut down something by mistake. Whatever.
The computer
Literally,
grew tired.
Rip.
literally
Okay.
says, wait a second. I mean, how do I flip the camera? Okay. Look at this. Literally says AV system is shutting down. Well, we can probably finish this before it shuts down. Come on, let's go. We can do this. So, where were we? Y prime p prime. No, wait. Y prime p of x, the whole thing prime, minus y prime p prime of x is going to be, we have that. All we need to do is do plus 1 minus x plus lambda all over x, p of x. Can you guys even see? I hope you can see.
No, we can't see anything.
Oh, you
No,
can't see,
but
really?
I can't see, but I can interpret your words.
No.
You know what? It might just be worth annotating on top of like Zoom right now just to like finish it off.
I'm not accepting this. Here, I'll solve with one hand and take a picture with the other.
Oh, what a god.
Absolute beast.
Whoa, this camera quality.
Okay. So I guess I'm gonna have to like solve and then like, you know, show, because I can't like,
That's
whatever.
Fine. That's fine.
Okay. So y prime p, okay. So all that's left now is, what is all that's left now? Y prime p prime of x plus. We're very close. Oh, all that's left now, in Sturm-Liouville form, you don't have y prime. So you see y prime p prime of x. You see that term, y prime p prime of x. That term is, okay. That term is going to have to be equal to 0, right? Because in the Sturm-Liouville form, you don't have you don't have y prime. Does that make sense?
Yes. Yeah.
Okay, so when that equals 0, that means dy dx multiplied by dp dx equals 0. Where do we go from here? Okay, dy dx times dp dx equals 0. Well, anyone have an idea on how you can find p? If you know this.
Where are we at?
Oh, we did. Here in a second. I think the system is back up again. Whoa, what the hell's going on? What in the world is going on? Okay.
I can see now. Like I can see the paper.
Okay, finally. Right. So dy dx times dp dx equals 0. How can we use that to find the answer? Trying to. Yeah. I have no clue actually. I guess let me just try one more trick. Well, I guess. What the hell? Oof. I thought this method never fails. What the? Yeah, I have no. I'm stumped. I don't know how to do this. Well, I guess I'm gonna give it one more shot. So let's think this part is x y prime prime. Take away x prime y prime. Minus xy plus lambda y equals 0. So I guess the answer is x.
Yeah, the
From
answer is
this-
X.
I'm able to tell like by my eyes at this point, so it means I'm just a small step away. What is p? What the hell is p? I just need to find. Literally, this got me to the same thing as this. What is this? Is it just okay? Is it? I'm gonna make something wild. I'm just gonna start guessing. What if it's just a constant? No, like not 0. Like p is a constant. Wait, is p a constant really? So cy prime prime minus xy plus. Oh, it is. Oh, okay. Okay. I guess the answer to this was that this is non-zero. So this has to be 0. Okay. Any questions?
Fair enough. Good job.
Can you move the paper down a little bit real quick?
Right.
Yeah, I just want to get all of it
Wait, down or
the other way.
down?
Yeah, this
Yeah,
way.
this
is
way.
good. Okay, yeah, that's it. Let me just get this down.
Basically, this is what you're looking for. This is like the mathematical proof that it is indeed x. And c is just a constant. Imagine this. Maybe I did like 4 or 5 problems of this. It was never a constant. It's always like some x squared, some e to the x, some kind of, you know, some weird function. It was never a constant. It never occurred to me that it could be a constant. So putting this like on an exam is very dirty. Very, extremely dirty. But yeah.
Awesome. Okay, I'm gonna go ahead and stop recording since this
What's
my
the
computer
last
now
term?
has like 9 or 7 hours of footage.
What's the
Is that-
last term in that box equation on the right? What's that last term before 0? Is
Lambda
that
y.
plus- Oh, okay.